Uh, Hello, Nivedita. Can you hear me?
You're audible, Vishwata.
And my screen is also visible, right?
Yes, yes.
Okay, thank you.
Hello? Hello? Hello?
Hello. Yes.
Hello. Good afternoon all.
Uh,
We will start the meeting at 2:10. Let's just wait for few minutes more so that other participants can join. Okay. You all are requested to keep your mics on mute mode. In case of any query, please type it in chat box. We will address it then and there. Thank you.
डायरेक्टर तक ना जाने के बाद अब जैसे मान लीजिए मैं पूरा पेमेंट कर दूंगा तो अगर कोई चेंजेस आप लोग प्रपोज करेंगे तो वो कर
Those who have joined later, we'll start at 2:10. All participants, please tell your friends to join, please. Please, you are requested to tell your friends to join. We'll start at 2:10 sharp.
I think we can start now. Okay, so first of all, let me welcome you all to this SPG SLB Hackathon 2025 that we are doing for the very first time. Before I proceed with the telling about the idea behind this event, I would like to first introduce the presenters who are over there with us. Can anybody just confirm that am I audible perfectly?
Yes, sir. You
Yes,
are
you
audible.
are audible.
Okay, thank you. While doing this presentation, I would request some basic decorums that we follow. As much as possible, avoid unmuting your mic. If there are any query, raise your hand and type your query in the chat box. And then and there, the presenter will try to address your query. Now, so we have with us from the SPG side, myself, that is Nikhil Singh. I'm the executive member of the SPG India body. I'm also currently working as the senior geophysicist surface with ONGC. And with us, we have Dr. Kaushik Biswas, who is the joint secretary of the SPG India body and superintending geophysics surface in ONGC. From the SLB side, we have Naumita Bhattacharjee, Nivita Pandey, Vishwendra Veer. I request just all of them to just say hi one by one.
Thank you, Nikhil. Thank you for introducing us. So myself, Naumita Bhattacharjee. I'm working with Schlumberger for last 20 years, and I'm leading the digital sales in Schlumberger. Really, really excited to be part of this hackathon, which we are doing for the first time in SPG platform. So welcome you all. Thank you.
Thank you, Namita. Vishwendra, you can speak now.
Hello everyone, I'm Vishwendra Veer. I'm a data scientist in SLB. I'm working with the SLB for the past 3 years, and today I will be talking about the hackathon, what we have to do, what are the expectations, etc. Yeah, thank you. Nivedita.
Thank you.
can-
Hello, hi everyone. Good afternoon. My name is Nivedita Pandey, and I'm working in SLB as a data engineer for almost 3 years now. I'll be one of the co-presenters for today, and we'll talk about Dataiku in detail. Thank you.
Thank you, Nivedita. Vishwendra, you can also ask the other presenters who are there.
Abhinit sir, can you please introduce yourself?
Hello.
Yes.
Yeah, hello. Yeah, hi everyone. So myself, Abhinit Sinha. So I'm a senior domain data scientist production, working with SLB. So I have been with SLB for 3 years, and overall in the industry, I have around 10 years of experience. I am a petroleum engineering by my educational background from ISM Dhanbad, and I will be talking today about the large language models and how we can integrate those LLMs in the data IQ that we'll be showcasing. So yeah, over to you, Nikhil.
Thank you, Abhinit. आपका introduction देने के लिए. Thank you for that. I think Ayush Agrawal is also there. Is he also a presenter for the today's event?
Uh, he will be talking in the at the end of the
Okay.
workshop. Yeah.
Okay, no problem, no problem. I hand over the mic to Kaushik Biswas sir. Please introduce yourself.
Hello, everyone. I'm Dr. Kaushik Biswas. I'm a joint secretary, as Nikhil already told that I'm joint secretary, SPG India, and I'm also associated with ONGC. I'm superintendent geophysicist. I'm working ONGC for past 10 years, and all the best for all the participants. Let's have a blast. Thank you, Nikhil.
Thank you, Kaushik sir. Vishwendra, just a small query is there. I'm receiving message from some of the participants that they're facing an error with respect to this joining the meeting. They're getting this error that your account does not have access, kind of thing.
It's
So,
an open thing.
but- yes, I agree.
Yes. And no one is in the lobby also.
Okay, no problem.
Yes.
I have just we'll deal with him later. Let's begin with the. Somebody has raised his hand. I would just request that let's just finish the introduction part first, and then we will
Yes.
take up the query. So Harshni, please wait till then. Okay. So thank you all for giving the introduction, and it's good to see that 114 attendees are there out of the 400, more than 400 plus registrations that we have received, and we believe that I think shortly all of them will be joined. One important message that I wanted to share with you all is this. We have sent 2 emails regarding this meeting with the meeting link as well as the participant group that we have created. So a small request is there. If you have joined the participants WhatsApp group, please make sure that your near and dear ones are in that group. If not, I will be contacting shortly at least one person from each institute so that we can have everybody on board. Okay, somebody is saying did not receive the email. Okay, no problem. It might be possible that the email might have bounced from your email. So we will see what can be done about it. Anyways, proceeding ahead with this, let me just give you the brief idea about what gave us the the idea behind this event. So going ahead with that, let me just give you a brief idea about the upcoming flagship event of SPG India. There is an 15th biannual international conference and exposition is scheduled from 26 to 28 October 2025 at Jaipur, Rajasthan, India. As a pre-conference event for the very first time, SPG team along with the SLB have come up with the idea of this hybrid hackathon competition. As you all are aware, those are from the student chapters. We have in the past conducted several student programs during or after the conference, but it was only limited to a SPG student chapter. But this time we thought of conducting an hackathon program that is open to all, in which professionals, academicians, and students all will compete in their categories. So basically, it's a program in which anyone can participate and learn. The idea behind this hackathon was simple yet powerful, to provide a platform where you can explore AI, which is fast becoming a current industry trend in the ENP sector. Whether you are a student or a professional or an academician, this is your chance to learn, experiment, and see firsthand what's happening in the field. This competition will run in dual phases, first virtually and then through collaborative finals. The details of it will be shared by Vishwendra also in the later part of this presentation. The format is designed so that you not only compete, but also connect, share ideas, and grow together. And obviously, you will hear more about it from our SLB team who are present over here today. And in this shorter while, to give the opening remarks, we will request our Norial sir, who is the Vice President of SPG, who will be joining shortly to this meeting. And then he will give a brief, give an opening remark about the idea. What is the idea behind this this particular event? So before I hand over to Vishwendra to take over ahead, I wish you all best of luck for the phase 1. And another thing is this: please keep a watch on the hackathon website. We will be giving the updates over there as well as through this WhatsApp group that we have created. So that is all from my side. I wish you all best of luck for this phase 1. Please make this please make good use of this opportunity. We have plenty of SLB experts as well as experts from the ONGC side to help you in addressing your query. And whatever queries are there with you regarding the registration part and the onboarding part, I'm sure that Vishwendra from the SLB team will take up very shortly. So that is all. Thank you very much. Vishwendra, you may take up ahead. I will ask Nori also when he will be joining. Okay. Thank you.
Sir, just 1 minute. Nikhil, I think Noriel sir is here, so you can ask Noriel sir.
Acha, Noriel sir is there? Okay, let me see.
Yeah.
I will enable his mic. I cannot see him here.
Sir has joined. Let me just call sir and make sure that he has joined. Okay, Kaushik sir.
I just called him and he told me that he just joined.
Okay. Vishwendra, are you able to make out his name? Because
under what name he has put
he
his
must have
username?
joined AK Noriel.
AK, no, just a second.
Okay.
सर आप कौन सा नाम पे ज्वाइन
Okay, just a second. I will allow everyone for a while.
Yeah, sir, if you
Yes.
can just unmute yourself, I have also unmuted
Just-
you.
Yes, sir. I think your mic should be enabled now.
Noriel sir is there in the presenters.
Yes.
Noriel sir, welcome to the first ever meeting of the hackathon event. Noriel sir, are we audible? I think sir has joined. Vishwendra, let's do one thing. Acha, Noriel sir, mic is on. Mic is on. Noriel sir, are we audible? Sir, आपका माइक अनम्यूट है बट वी आर नॉट एबल टू हियर यू.
Nikhil Singh.
Yes, sir. You're audible now, sir.
Nikhil, I am audible.
Yes, sir. You are audible, sir. And sir, we have given a brief idea about the event. That what was the reason behind that we come up with this idea behind the hackathon event. Please, sir, I request you now to give your opening remarks and share with all the attendees who are there with us now. Okay, sir is here. Please, sir.
Yeah, yes, Nikhil, can you hear me?
Yes, sir. You're audible, sir.
Okay. So then you are going to start?
Sir, I have given a brief idea about the event already, and we are waiting
Okay.
for your opening remark about this event, sir. Please, sir.
Okay, okay. Thank you, Nikhil. Thank you. So I think how many participants? 89 people have joined.
Yes, sir. 127 have joined, and many more are also joining shortly.
Okay. Okay, at the onset, I welcome you all for the first ever hackathon jointly organized by the SPG India and SLB. This is truly an innovative idea in which we are a combination of innovation, technology, and collaboration within the companies. And as you know, the participants are truly diverse from different areas. People are joining for, I think, 402 students, out of which 61 are professionals, 9 are academicians, and 90 women have also participated in this hackathon event, and around 400 men have participated. In a true sense, this is we can say a startup, or we have started our SPG conference 2025. I welcome you all, and lot of representation have been from distinguished universities like IITs and ISM Dhanbad, BHU, NGRI, RGI, PT, UPS, ONGC Oil India, and Schlumberger Indian Oil all have actively participated in this hackathon event, and lot of efforts have been given by Schlumberger, and I am really thankful to SLB for partnering in this hackathon event. As per the conference theme, from rock to cloud, let this hackathon be a bridge with bold ideas which power the energy of evolution. I welcome you all and thank you to make it a great success. Thank you, Nikhil.
Thank you, sir. Thank you for your kind words. And
Thank you.
With this, sir, we will officially we can launch the phase 1. And I now hand over to SLB team Vishwendra for carrying out the necessary formalities. So that is all from our side. Thank you, sir.
Thank you. Thank you. Thank you. Welcome, Vishadhar.
Thank you, sir. Thank you, Nikhil, sir. Okay, so let's move ahead with
Yes.
the meeting with the hackathon. So I will just talk briefly about the SPG. So it started a long back in like 92 in Dehradun, and since then we have 11 chapters, regional chapters. We have 16 student chapters, and we have come a long way. You can see there are so many student chapters mentioned in the map, and we have the endorsing society, the SEG and EAGE, and also the Australian Society of Exploration Geophysicists. It is an affiliated society with the SPG. So yeah, we have come a long way, and with this hackathon, we will bring the SPG to uh, another level. So let's go ahead. So I am working in Innovation Factory. So Innovation Factory is basically a branch of SLB, which specializations in AI. So the Innovation Factory, it consists of data scientists and domain data scientists. So data scientists are like which are coming from the data science background, and domain data scientists, those are the people who has experience as well as knowledge in domains, in their respective domains, be it geology, be it geophysics, petroleum reservoir, anything. Then they have gone through intensive training of data science, then then they become the domain data scientist. So the idea of Innovation Factory is basically to integrate our digital expertise of SLV, the domain knowledge, and the technology foundation. And these all three pillars, we all are working towards the customer centric problems, so that we can help our customers. So as you can see in the world map, we have 7 innovation factory centers across the world, strategically positioned so that we will be as close to our clients. And our New Delhi is the most recent one and the last one also. So we were lucky to have a innovation factory in India. So let's go ahead. So the vision of Innovation Factory is basically to accelerate and adoption of AI and innovation to solve business challenges. So this is our mission, and our mission is basically to deliver rapid customer value in AI and digital customer innovation engagement, to help accelerate digital transformation and business impact to AI and digital solutions, and most of all be close to our customers so that we can work in a collaborative way, and all the knowledge of domain, all the knowledge of data science, and other IT infrastructures. So we try to combine all of them, and to solve our business problems. So this is a brief introduction about the Innovation Factory. Moving ahead, so this will be our agenda today. So I will be talking about the hackathon. Then Nivedita will take up to the introduction of the AI/ML platform, that is the Dataiku. Then we have a use case demonstration. Then we will talk about LLMs. Then I will talk about the guidelines to access the data. And lastly, we will have a Q&A session. But don't worry, we have a few breaks within the session. So going forward. So this is a dual phase hackathon. Uh, the theme is from competition to collaboration. So first, what you will do, you will compete against each other, and in the phase 2, you will collaborate with cross teams, and that explains the theme of our hackathon. Moving forward, so basically, the phase 1 is the virtual challenge, where the teams will work independently. I will provide you a common data set, and you have to build something, some innovative something, and then there will be a shortlisting, and then the phase 2 starts, which is the collaborative finals. And the interesting thing about the phase 2 is there will be a reshuffling of teams. So we will ensure that each team will have as much diversity as possible. It should have a data scientist, it should have a geoscientist, it should have someone from academia, it should have someone from corporate, someone from ONGC like PSUs. So we will try to get as much as diversity in a single team. So there will be the flow of knowledge, there will be networking, there will be uh, what I can say, like maybe we can come up with a very innovative idea when there will be a collaboration within the teams. So that was the most interesting thing about the collaborative finals. And students, professional data scientists, geoscientists, anyone who wants to participate can participate in our hackathon. So this is a basic idea about the hackathon. Moving forward, now the challenge of the phase 1. So basically what you have to do, so you can the theme of the phase 1 is seismic or well logs interpretations or insight generation using AI. So the AI component is very necessary. So whatever you want to build, you have to use AI in that. But don't worry, we have a Dataiku platform. If you don't know how to code, or if you are not very familiar with the coding, we have a low code, no code environment in our Dataiku, which we will be showing. So even if you don't know how to use Python, you will be able to participate in this hackathon using our platform. So the challenge is seismic or well logs interpretations or insight generation using AI. Now, the phase one, what you have to do. So we will provide you a data set and you have to identify a problem which you can solve using that data set. So the problem could be anything uh, from your respective domain. Suppose if you are working in some geophysics field, you can identify a problem related to your field, and what you have to do, you have to develop a prototype. Just a second. Yes. Yes. So basically, you have to develop a prototype. You have to identify a problem, then then you have to develop an AI prototype, and you can use any tools like any frameworks or AI assistants. And if you use our Dataiku platform, which is very uh, advantage if you use it, so there will be extra marks if you leverage the Dataiku platform. And the thing which you should avoid is you should avoid focusing on seismic processing, because it takes so much of the resource and it takes so much of the time. So any solution or any prototype, if you are uh, thinking about doing something in seismic processing, please drop that. So the possible areas of focus: seismic interpretation. We have well log interpretation and processing. What you can do, you can generate insights from technical reports, or maybe you can uh, integrate all three things and do a integrate seismic well and reports. So this is possible area of focus, not limited to. You can go beyond it as long as it has some value in the which I will be presenting in the next slides. So this is a possible area of focus, but not limited area of focus. You can build anything. So, but the prototype and the problem statement, the data you will use will be only the data which we will provide. That is the only limitation. So you have to develop your solution using our data set only. So yeah, so now you know what you have to do. You know the possible area of focus. Now going forward. So the key expectation and judging criteria. So the key expectation is whatever you will build, you should demonstrate innovation, the creativity and novelty in your approach. It should have a real world impact, whatever it would be time reduction, it would be cost saving, it could be increasing efficiency, it could be accuracy improvement, anything, but it should have some real world impact, whatever the solution you will be developing. So it is open, you can identify any problem, you can build a solution to solve that problem, but it should have some real world impact and it should demonstrate innovation, creativity and novelty. And please select those problem statement which you can uh, complete. So you have to deliver a working end-to-end prototype of a solution, and then you have to make a pitch deck. You have to make a pitch deck which has the format I will be discussing a while. So you have to present a solution with a clear and concise pitch deck, and you also have to submit your code along with the if you are using the coding functionality of Dataiku, then you should provide the documentation of the codes also. So these are the key expectation. Now the judging criteria. So your solution and your idea both will be judged based on the innovation, the creativity and the novelty, the impact, the level of impact in the real world, how clearly you are presenting it, the completeness of the solution, and also the use of Dataiku platform. So this will be the judging criteria and the key expectation. Uh, Moving forward. So phase one, submission requirements. So basically, I believe most of you are familiar with the Shark Tank. So like that, you have to make a pitch deck. So the pitch deck should have maximum of 10 slides. It should contain the problem statement and why it matters, why you are solving it, and the proposed solution. What are the tools and the extra data you will be using, the prototype and the architecture, the value addition and the impact in the real world, the innovation and the creativity which you have put into your solution, and then the future scope of work, like what will be the next steps, what are your plans, like how to improve this solution more, because most of the solution, like I believe 95% of the solution can be improved. So these are the things which should be present in your submission. Uh, Going ahead. So basically, what you will be submitting, a pitch deck, like I have explained earlier, and the codes and the documentation. And also I will uh, let you know how you will submit all these things. So you have to submit all these things inside your Dataiku project, which we will be demonstrating how to do that. And the submission guideline was 1st October, but we have extended it for 2 days. Now you have 2 extra days. So now the deadline is 3rd October. And so whatever you have plans to build, whatever the problem you have identified in your field, whatever the solution you will be making, please make sure that it will be a working prototype, and you have to submit all these things before 3rd of October. So uh, this concludes my part. Now Nivedita will be taking care of the Dataiku platform. I will just brief you what it is. So basically, Dataiku platform is AI for everyone. If you are coming from any field and you don't have much knowledge of coding or any knowledge of coding, but you know, okay, I have an idea and I can solve it using AI, then this is the platform you were looking for. So Dataiku platform is basically AI for everyone. It is accessible to all, and we will be providing this training and support to familiarize you with the Dataiku platform, what are its capabilities and everything. And it has integrated environment, so it has so many functionalities which you will be seeing in a while. And also there will be marks if you extensively use this platform. uh, the reason behind putting the evaluation advantage is because it has so many functionalities. Once you explore it, you can go beyond. Like suppose you were trying to build something, now you can build that thing into a smaller shorter amount of time, shorter span of time, then you will have extra time to improve your solution. So if you will use this Dataiku platform, the solution you will be building, the time will be cut short by uh, very much amount. So this being said, uh, I will hand over this to Nivedita. Please, can you share your screen and tell about
Yes.
this?
Thank you. Thank you, Vishwin, for the introduction. Let me share my screen. Can you please confirm, Vishwendra, if my screen is visible?
Your screen
Can you
visible,
put
Nivedita?
can you put it in the presenter mode?
Yeah, yeah.
You might want to share some. Yes, perfect.
Okay. So, good afternoon, everyone. My name is Nivedita, and thank you all for joining this workshop. And today we are going to take a dive into Dataiku, which is our AI ML platform, and it brings together different facets of data from preparation to machine learning and collaboration all under one roof. Now, I'm sure maybe some of you are familiar with Dataiku and others may be hearing it for the first time. So my goal would be to make sure that everyone, walks away with knowing what Dataiku can do, and also we have a good understanding of why is it such a powerful tool for our day-to-day work. So just a brief about how we'll be doing this session. So the first 20-25 minutes, I'll be going through the concepts and features in detail. And then I'll show you a demo with a real oil and gas scenario example about facies classification. And that we can see both the big picture and the practical application. Now, I kindly request all of you, if you have any questions during the session, please post them in the chat box and our team would be happy to address them. And this way we can also stay on the schedule and manage the time. Yeah, so this is the agenda. So first of all, I will be talking about Dataiku, then we will have a look at few concepts, and then I will show you hands-on the Dataiku. Now, talking about Dataiku, as you can see, it is called as the platform for everyday AI, and it is positioned as an end-to-end data science and analytics platform. So why is it called as an end-to-end? This is basically because when we start connecting with the raw data, and it might sit across different platforms, maybe in databases, maybe in data lakes, sometimes in cloud storage, and sometimes in legacy applications like Excel files. Now, after having getting the data, the next step is to prepare the data, because we all know that when we deal with the real data in the real world situation, it consists of multiple problems, like there might be gaps, there might be duplicacies. So the next step is the data preparation, followed by the visualization part, so that we are able to understand the data better. And then some of us, depending upon our profiles, we might want to build models on top of that, and sometimes visually, sometimes with the help of code in our script, in our language of preference. And finally, once we get some insights, we might want to share those insights with our team members or with different stakeholders. That can be in the form of dashboards or reports. Now, normally what happens is that we might need multiple different tools for each of these steps. Plus, there is a coordination that is required amongst different teams. But with Data IQ, it brings all of these into one single platform. So that is the value proposition with which we will begin. This is a single space where people from different domains and backgrounds can work together. Now, as I already mentioned about the end-to-end platform, let's have a brief look at the three most powerful capabilities. First is about the democratization, which means in simpler terms that it enables or helps the collaboration between the data scientists, data engineers, domain experts, and developers all working under one platform, so that they can share their insights and understand the overall workflow together. And by democratization, it also means that this is a very low code, no code environment where people from different backgrounds and different proficiency levels in coding languages can actually use the different options that are available within the platform to leverage and to solve their problems. Second is deployment at scale. So this basically means that in the data and AI world, we know that AI is everywhere, but without the need of having any kind of specialization in deploying our applications or workflows, how a single person can actually make the deployment easy, and they can take the advantage of, again, a low code DevOps environment to sustain their machine learning environments. And lastly, the enriched workflows. So I think one of the most important things that Data IQ provides is the pre-built integration capabilities. And as we can see here in the picture on the right-hand side, that this enables you to connect or integrate with wide variety of applications, be it the petrol technical suite of applications that you use, or it can be the OSDU platform of choice. So with these features of the platform, it actually helps us to deliver the experience more easily and collaboratively. Now, as I said about the integration part, I would just highlight that these are the different or the wide range of data sources that Data IQ can connect to, and these are just a few. There are much more. They are much more in number. Just to take a few examples, you can connect to Microsoft Azure Blob Storage, be it MongoDB or Snowflake. And in fact, there is also the presence of enterprise scale systems. For example, the SAP HANA or the Azure Analytics Workspace. Now, Data IQ DSS. So Data IQ works on the concept of DSS, or we call it the data science system. So how does it actually makes our work easy is, first of all, it can help you to connect to the wide variety of data sources. And as I already showed you a few examples, so you can just connect to any of the data source that you like with just a few simple clicks. Next is the data exploration part, where Dataiku helps you to understand your data in any format by making it a tabular representation, and also using different kinds of visual analytics tools that are present within the Dataiku. You can create your own kind of visualizations, be it chart, be it statistics, be it anything. Thirdly, you can maintain your data flows, make it sustainable so that they can be reused by different teams. And with Dataiku, the overall flow is very easy to understand and intuitive. And as we'll be looking at that in more detail in the upcoming slides. So it makes for the end users or for someone who is viewing the flow for the very first time, it makes it very easy to understand the entire logic and how the data goes from the start to the end of the model. And data preparation, as I already mentioned, so Dataiku leverages the capabilities of more than 100 plus built-in processes to perform all different kinds of advanced operations. And lastly, since it's very good and important to work on the data, but what is the use unless we are able to share our insights with our different team members and stakeholders? So with the visualization capabilities and more than 25 chart and map types that Dataiku provides, it really makes our task easier. Now, I'd like to take a brief moment to explain the very high level architecture of how Dataiku works. So we have the end users who use any kind of browser to access the interface of Dataiku using a simple URL. And in the center sits basically a server, which is a Linux-based server on which Dataiku is deployed. And then on top of that, we have the user-based or user-specific interaction nodes, where you can, as I mentioned, build different kinds of visualization tools and complete your coding environment and collaborate with others and make a fully fledged working app or machine learning model or anything of your choice. Now, in this diagram, I would like to highlight, first of all, the flow or the machine learning flow model that you see over here. And as we can see, this is represented by arrows and the different kinds of data sets, some of them colored in blue, some color coded in yellow and green. I will have a look at each of these in more detail. But on the left-hand side, we see that all of our data, this is the raw data or the data that is sitting in your systems. And once you bring all of your data, connect to your existing data sets, the next step is the preparation of the data. Once the data has been prepared and ready to be analyzed is when we deploy or run our machine learning models. And this entire process can be automated. It can be automated to run one time, multiple time. It can be scheduled according to the requirement. And all of this, again, can be monitored using the various governance and auditing features that are present within Dataiku. So there can be administrators, there can be editors, there can be viewers who can work on the project as and when required. Now, on the right-hand side, we see the different visual and the coding elements that are part of the Dataiku, which help us to make our task easier. For example, the LLM recipes, as you see on the top now, as Vishwendra mentioned, that Dataiku is a platform which is made for people from diverse backgrounds. So even if someone is not proficient or does not have a very grasp on the coding language, you can use these recipes which are already trained on the models and deploy a workflow diagrams. Then we have the visual recipes, which again make our task easier. And then there are specific code recipes for people who have a very good understanding of coding languages. They can use and play around using the different languages of their choice. Now, just let's have a look at how it is a collaborative platform. Now, what happens in most organizations that we see, we have people from different backgrounds who are working with data. On the top, we see, for example, there is a business analyst who might not be writing code every day, but they know the business processes and they want to communicate the same to their team members. So Dataiku gives them this ability to do the visual data preparation and then run the AutoML. Now next comes the data scientist, who are definitely prefer coding in their language of choice, and they can still do everything they normally would in notebooks. But now with this platform, their work is connected to the rest of the team, so others can also work together and on top of that, they can actually monitor the performance of their models. Next, you see here there are analytics leaders. So their focus is more on the insight and the validation part. So with Dataiku, the leaders or the data managers, for example, they do not have to chase multiple teams for the updates and asking on mails or on Teams. Rather, what they can do is they can actually directly visualize the results. They can validate the outcomes, and they can also drop in their comments for if they want to change something. And on the very bottom, we have the data engineers, definitely with whom everything starts from the foundational people who work on the data and the preparation part. So they make sure that everything is running reliably at scale. Now having talked about Dataiku platform and what it is based on, who is it made for, and how one can work together as a team, let's have a look at the various concepts in DSS. So this is how the homepage of Dataiku looks like when you create a new project. And let me walk you through this. So as we can see over here, we have the name of the project. So the project that you create, for example, this is the West Nile virus, the project that has been created. And it highlights the name of the person who has created the project along with the date and the year. Now, if there are multiple people who are working on the projects, their name will be certainly mentioned over here as my pointer points out here. Then we have the flow. And as I already explained that in Dataiku, everything is basically a flow diagram. So all the data sets, how many recipes are used, how many models are used, this is a kind of a statistics that one can refer to for getting an overall summary of what my project is about. How many notebooks are there? What is the analysis? If you want to directly go to the flow, you can simply click on the yellow button pointed over here. And next, if, for example, you are sharing the projects with multiple people and you want to highlight a description about what the project is about, you can add the description over here. And on the top right side, we have, as you can see, this is the timeline. This is the kind of the audit trail that I was talking about, that if there are multiple collaborators and if you want to know who edited and what did they do at what particular time, what changes have been done, this will be highlighted in the timeline section on the right hand side. So yeah, I think I already explained this. Moving on. Now, since I already mentioned about the flow, so as you can see, we have the different kinds of data sets that are a part of the flow. The yellow colored circles over here, they represent the different recipes, and green color over here, they highlight the machine learning model. So this is all color coded, and just give me a minute. They are color coded. And next, the data sets, they can be of from a wide variety of sources and of different kinds. So it can be from different kinds of storage types. It can be simple Excel files or a SQL database or HDFS or a cloud storage. So data sets we already went through, and once you have actually imported your data sets, you can start working on the data and interact with it. For example, you can use the visualization capabilities, or you can transform the data, which we will look into more details in the upcoming sections. Now, recipes are always highlighted in yellow in Dataiku. So we have two different kinds of recipes, namely visual recipes and code recipes. Now, so you input your data, you do the different kinds of transformation, for example, splitting the data, filtering the data, window function, joining, filtering, ordering, and etc. And then you get the output or your prepared data set. And these are the three different kinds of recipes. The yellow ones, they represent the visual recipe. The orange color, they represent the code recipe. And red color represents the plugin recipe. So for example, if you're choosing, let's say Python for preparing your data set, for example, for removing the duplicates or for replacing the missing values, you can use the code recipe. So that will be highlighted in yellow or in orange. In the flow diagram, if you're using any kind of plugin for integrating with an external sources, for example, as we saw, then you might use the plugin recipe, which will be highlighted in red in the workflow. So I think this is how the flow works. We have the input data, and then you apply your logic using the recipe diagrams, and then you get a prepared data set on which further we can apply further more logics to get the resultant output. And yes, so the recipes, since they are the probably one of the most important aspect of Dataiku. So these are the different kinds of visual recipes that Dataiku provides. So for example, just to name a few, we have the sync, prepare, sample or filter, group by, sorting, splitting, and so on. For the code recipes, we have different languages that are provided: Python, R, SQL, Shell, and so on. For the green color, as I said, they represent basically the machine learning model. So what kind of model do you want to apply to your prepared data sets is what you can choose from here. And finally, we have the plugin recipes. So if you want to do any kind of time series preparation or graph analytics is what you can choose from the plugin recipe section. Now, since I've multiple times mentioned about data preparation, so data preparation is in fact one of the first and the very important steps that we begin with, and we can use the visual recipes or the coding recipes to prepare, clean, and format the data. Now, most of the cleaning steps is done using this prepare recipe, and that is represented by this particular icon, as you can see. And every time, as mentioned over here, every time you add a recipe, so Dataiku will create a new data set. And one more thing, so the beauty of the prepare recipe is that it captures every step that you take. So instead of just modifying the data set directly, so Dataiku will create a new data set each time. So which means that your raw data will remain untouched, and you will always have a clear audit trail, and you can always go back and adjust your steps at any point without losing any of your work. Yeah, so as I mentioned about the data visualization or the exploration capabilities that Dataiku provides. So once we have prepared our data, the next step is exploration. And this is where we start telling the story to the audience. So what you see here are a few built-in visualizations that Dataiku provides out of the box. For example, on the top left, we have this kind of a scatter plot, and then we have this donut chart on the bottom left, and then this is a bar chart, which is the count of records of the gamma ray. So this is how we can actually tell the story to our audience using the different kinds of charts present in Dataiku. And not only this, for people who are deploying their machine learning models, you can use the statistical analysis on your data to understand how well my different parameters are correlated. So this is an example of a correlation matrix that has been generated on the data set. And then there are different kinds of analysis, other different kinds of analysis. For example, we have the univariate analysis or the bivariate analysis. Univariate is, for example, if you want to see how my each individual parameters, how are they distributed, you can use the univariate analysis. If you want to see the relationship between two different attributes, you can use the bivariate analysis. Now, this was an overall overview of Dataiku with a brief about the recipes, the flow, the diagrams, and everything. Now, in the next part, I would like to show you or demonstrate you about one of the classic examples from oil and gas, which is the phases analysis. And I will show the workflow end to end, right from importing the data set to deploying the ML model. But before that, I think we can take, since it has been almost 1 hour since we started, so we can take 10 minutes break. So we can resume the session at 15:10. Vishwendra, if that's okay. Hello, Vishwendra or Abhineet, sir.
Yeah, let's
Yeah,
take,
Nivedita, I think it's okay.
Okay, okay. So let's have a 10 minutes break and let's resume at 15:10. Okay, I hope everyone is back. If someone can just confirm they can hear me again.
Yeah, you can start. I think.
Okay, okay. Thank you so much for the confirmation. So, okay, so yeah. So before I begin with the demo session, I would like to actually explain what data set we are going to work upon, which is the species classification. This is a very classic example which is used in the oil and gas industry. And as we all know, so species is they are the sedimentary bodies of rock which are characterized by their deposition environment or sedimentary structure and their grain sizes. Now, why are we taking this kind of an example? Is because it will help us to increase the knowledge of the subsurface using machine learning, because definitely we do the interpretation and we are aware of the conventional methods of interpretation, but how we can leverage data IQ specifically for doing this kind of a classification. Just a brief about the data set. So these are the different features or the columns that are present in the data set that we will shortly look into. So we have the data for gamma ray, resistivity, photoelectric effect, and so on. And these are the different labels that are used again within the data set. Now that I've already shown about the dataset and this example, I would now begin with the demonstration part. And for that, so this is how the homepage of Dataiku, once you log in using your credentials, this is how it looks like. And as you can see, this is the home page, you can call as the AI workspace. And this is the user profile. Once you have created your account, your name along with your credentials will be highlighted over here, and the different projects will be again visible. Now, if I have to basically click on a new project or create a new project, so what am I going to do is going to click over here, which is a new project, and then I will select blank project. Now, I can basically give any name to the project, but it is always a good idea to give names which are self-understanding and intuitive. So let's give this as species classification workshop. And this is the location of the project where it will be hosted. And I can click on create. So now once I click on create, the project will be created for you, and this is how it will be reflecting over here on the home page. This is the name, and you can edit name of the project if you require, and who it is created by is their name or credential is highlighted over here along with my name, since I'm the only person working on this. But if there are multiple people, their names will be highlighted. This is the timeline. So this is the timeline tab. This tells us how many edits or changes have been done and at what timestamps to, to maintain the audit trail. And then this is the flow diagram or the flow statistics, that how many data sets, recipes, and models are a part of this particular workflow. So to begin with, so first step first is to get the data set on which we are going to work upon. So we need to click on this, import your first data set. And as you can see over here, we have multiple options to actually import our data. It can be simple Excel files or different files that are present or sitting within your systems. Can be big data like Hadoop or SQL databases, cloud storages. But just for this demonstration purpose, we will choose the Excel files that are present within my system, and I will go and click on select files, and then I have my data which is present within the folder. So I will just select these two data sets and click on open. Now, once that is done, create multiple data sets, create and next. Okay, now as you can see, I have already imported my data sets, and then they are highlighted on my Dataiku homepage. And if I want to have a look at what exactly the data set contains, so let me double click on the first folder. And once you double click, so this is the kind of a tabular grid info that will pop up. So this contains basically two columns, which is called as facies and the facies type. So there are 9 different facies that are presented as a part of this data set, and one represents, for example, the non-marine sandstone, two represents non-marine coarse siltstone. So that is the designation or the order that it follows. And every time, let's say every time I'm on any of the pages and I want to go back to my flow, so I have to click on here and go back to the flow. You can use the keyboard shortcut, which is G+F. Now let's have a brief look at the second data set, which is the facies vector screen. And as we can see, so this is the number. The number definitely donates what is their facies type, which we saw in the previous data set. To which formation do they belong? What is the well name? At what depth are they located? And GR, for example, the gamma ray log, the phi resistivity log, the photoelectric effect, and so on. This is our entire data set on which we are going to work today. Now, again, I've inspected my data. I can go back to the flow. So before I begin doing further things, I would like to custom you to this particular interface. So once you click on this, this is called as the top menu bar. And over here, you have different options to go to the flow, to go to the data sets, to go to the recipes, models and agents if you have deployed any, and so on. Now, this is the shortcut for your models, which I mentioned, the green color ML models. This is for going to your code notebooks, web apps, libraries, and so on. This is if you have some advanced jobs or some scenarios that you have deployed, which is basically kind of a scheduler that you want to run at which particular intervals every 1 second, 2 seconds, just for an example. This is how you can go to those tabs. And this is wiki, definitely the documentation, the help, or rather I should say the help center, where you can navigate for searching anything of your interest. And then this is the dashboards tab, and we will look at a few of these in more detail as we move across. And over here, if we select any of the data set, once you select, then this is the actions tab that pops up over here. And you can see we have the lab, which is basically the visual analysis or the machine learning models that you're going to deploy. This is a list of all the visual recipes, which I talked about in my overview part. These are the code recipes. At the bottom, we have the LLM recipes, which will be covered in today's workshop. And at the very bottom, we have the plugin recipes. Now, there are different kinds of plugin recipes that are built in within Dataiku. Now, definitely, all of them are not free. And some of them are paid over here, depending upon the access level that you have got. And there are a few other recipes, for example, to evaluate the performance of your machine learning model. We had this kind of evaluate recipe. And then there is this flow zones and some other actions. Now, there are a few tabs which are present at the bottom. So they do more or less the same job. For example, if you want to add a recipe directly not from here, but from here, you can do that. You can, if you want to add a data set to your project, you can select here and some other basic options. So now that I have my data set and I have briefly explained you about the interface and how it works, and we have imported our two data sets on which we are going to work today. Now, let's go on to the next step, which is we want to join these both data sets. So what I'm going to do is basically I'll select this particular, and then I will click on I'll click on the join recipe. So with which data set do I want to join? I have to join it using with the facies labels. And then what is going to be the name of my output data set? So I have to click over here and write facies with labels. This is the name of my output data set, which I'm going to get after joining both the different data sets. And then I can simply click on create recipe. So now once I have clicked over here, so now how am I going to join? The first question, once I've created join, but what is going to be the criteria of joining these two data sets? So I can actually select that, go to the selected columns tab, and then I can select all columns. Okay, and select all columns. Manually select columns, sorry. So we need to select the manually select columns, and from here what we are going to do is basically we will uncheck the faces because we don't need this. Why we don't need this is because this is exactly what we are going to predict using our machine learning model. So we will not select this column after joining, and all the other columns of my interest like formation, well name, depth, and everything I have selected, and then I can click on run. So run is basically if you have performed any kind of task, be it any kind of recipe, any kind of code that you have deployed, you always have to click on run for this to take or to save or to run this on your data set. So let's wait. Will take some time to run. Yeah. So as you can see, my job is succeeded. If you want to view more details, you can click on the view details tab, or else what you can do is simply again go back to the flow over here. Now here we see that my data set, both of the data sets have been joined using the join recipes, and I got an output or a resultant data set, which is called as the PCs with labels. Now let's explore this data set of how it looks like. So as we can see, we have the columns from the faces with vector screen data set, and we have the column which is faces and faces type from the other data set. Now I will return to the flow, and what I will do is click on this data set, and I want to prepare. So as a part of preparation, I might want to rename a few columns. I might want to see the statistics. So I can simply click on this data set, and from the right panel, we can select the prepare recipe. So once again, it has selected the input data set is selected by default, and the output data set is again, it gives a name by itself. So you can either go with this name or you can give a name of your own choice, and then you can click on create recipe. Now, once this recipe has been created, you need to add steps to your recipe to exactly what do you want the recipe to do. For example, I can click on add a new step. And as I said, we want to make the column names more intuitive for anyone to understand what they actually represent. So we have this is a library of different kinds of recipes or different kinds of options, rather steps that you can do to prepare your data. And we will select the rename columns. Now, once you do that, you can click on add renaming. So what you want to rename and what is the output that you want it to be. So for example, I want GR to be renamed as Gamma. I want to add a few more renaming. So I want ILD. So it is already highlighted. You can just click on enter. And what do you want this to be renamed as? Resistivity. We will similarly do a few more, and then we will move to the next step. Yeah. So for the time being, I'm just renaming a few columns, but you can always rename the rest of the columns according to your requirement. This NM_M stands for non-marine or marine indicator. Yeah. So for example, if you want to rename more columns, you can just do that, add more renamings, and once that is done, you can click on run. So we will wait for this job to be finished. Okay, so we can see that the job has been succeeded, and once it has been succeeded, I can go back to my flow. And now this is the data set, the output data set that we get, which is called as faces with labels prepared. So you can again double click and try to explore this data. So as we can see, we have the different well names, the gamma ray resistivity, photoelectric effect, and so on, the different columns that we got after preparation. And as you can see, in the original data set, we had GR and resistivity. So yeah, we have renamed this. There's a spelling mistake, but we can ignore that and go back to the flow. Now that our data is prepared on a first-hand basis to start work with, let's see and let's try to see how we can actually visualize the data. So what we need to do is open this data set and let's have a look at the visualization. So you have to go. So as you can see on the top as well, we have different kinds of options to explore the data sets. For the charts, we have options for the statistics. So now we will explore the charts option and how we can create a visualization of our choice. So we can select from the drop down over here. There are multiple types of chart options present, as you can see from the drop down menu. And for the sake of demonstration, let's create a donut chart. Now, donut chart, so you want to show what? So it gives you the indication, like you want to drop the set of size of slices and by what parameter do you want to drop. So I want to show the count of my records. So how much data do I have? And by is going to be my well name. So this is as you can see, just with few simple clicks that Dataiku provides, you can create a chart of your own choice. So this is the donut chart, and this represents that how many well names are present in my entire data set, and what is the count of each data for each well name, data sets for each well name. So this is the donut chart, and if you want to make more different kinds of chart, let's take another example. So I can click on plus chart over here, and let's try visualizing a kind of a line chart. So for the line chart, now you need to specify what is going to be, you have to drop to set the height of the lines, and then by x-axis, you want to drop to set the x-axis. So for the y-axis, I'm going to select my gamma ray because I want to see how my gamma ray is evolving as a matter of depth. So let's select by depth. And yeah, so this is how you can see that how my gamma ray values actually vary as a matter of depth. Depth is represented on the x-axis, gamma ray is present on the gamma ray values are present on the y-axis. Now, yeah, so these are the simple kinds of visualizations. You can obviously create more charts of your choice by clicking on this plus chart icon, and you can select charts of your choice, and you can just play around with the data and the different options that it provides. Now, after having looked at the charts, let's go back to the flow. And now we have seen how we imported the data sets. We then used the join recipe to join both the data sets, and then we did a preparation recipe to prepare the data set by renaming few of the columns. Now to begin with training the model and evaluating how my model is actually performing, so we have to first of all build a machine learning model. So for that, we will be using the faces with labels prepared data sets. And once you click on this, first of all, the first step in any the kind of model that we are going to deploy is, first of all, we will split this data set into training and the testing data sets. I'm sure everyone is aware of these basic concepts. So for this, we will use the split recipe. If you want to split the data set by any percentage or by using a formula. So from the visual recipes, we can click on split. Yeah, so this is the split. And what is going to be my output data set? So first data set is going to be my train and create data set. And the second data set that I'm going to is going to be the test. Now this, you have to click on create data set. And once these both are created, then you have to click on create recipe. Now splitting has been done, but splitting has not been done. And what method of splitting would we like to choose? So there are 4 different kinds of options. For example, you want to map values of a single column, or you want to randomly split your data without any hidden pattern, or you want to define the filters. So for the sake of easiness, let's choose define the filters method. And after clicking over here, you have to actually provide basically which one would you like to split. So over here, let us select, since I want to split my I will click on test and match the rows that satisfy a formula. Now the formulas, so Dataiku uses some language of its own, which is used for basically satisfying the filtering condition. But if you want to use any different kind of condition that you want to, for example, where formation contains XYZ values, or you can choose, for example, my well name is equal to shrimplin. So then we can choose that. But we will go with this formula and we will type a formula over here. So let me type that formula. So yeah, I've already have the syntax with me, so I will just simply copy it over here. And then what I will do is all other values for the training data set. So I want to filter my test data set based on a formula where my well name is equal to shrimplin. So my test data will only consist of well data, for which the well name is shrimplin. So all the shrimplin data set will be a part of my test data set, and the rest of the data corresponding to other wells will be a part of my train data set. And this is what I will be using for training my machine learning model. Now, once we have defined these filtering conditions, you can see both are ticked as green, which means it is correct and valid. Then we can click on run. So it will take some time to run the split recipe on the data set. Let's wait for that. Okay, so this is, as you can see, the job is succeeded. And now once it is succeeded, let's go back to the flow. And as you can see, my prepared data set has been split into training and the testing data sets. Now, let's click on the test data set to see what it is. And as you can see, it contains 471 rows with 12 columns. And all of these rows are corresponding to the shrimplin well names, since this was the filtering criteria that we gave in our splitting recipe. So let's go back to the flow. And now, so we have done the preliminary task of splitting the data set, followed by preparing the data sets to be ready for the machine learning model. And then as a first step of my machine learning model, I have to train the model. I have split my entire data set into training and the testing data set. Now I want to train my model, so definitely I'll be using training data set. So let's click on train data set. And on the right hand side, as you click on any data set, this is the lab icon you can see over here. So click on that. And you have different kinds of visual, again, it is a visual machine learning models that pop up over here. So you can select. So for our purpose, for our use case, we will select the auto ML prediction. So now what do you want? What kind of analysis do you want? So I want to predict the facies type. So I will create a prediction model on facies type. And this is the quick prototype is one that I'm going to be using. And then I will click on, if you want to name your analysis something else, or else you can simply click on create. Yeah, so you can see that this is my modeling that has been created. And then we will go to the design tab. Now, let me take a moment to explain. This is one of the most important aspects of data IQ visual analysis, which is the design tab. So the design tab makes sure that it provides you with various features that you can tune and tweak according to your requirements. For example, starting with the basic, this is the target. So what is the target that you want to predict? So I want to predict my facies type is what is highlighted over here. And these are the different target classes. So this has already been computed. And as you can see, what is the percentage of non-marine coal siltstone and fine siltstone and so on based on the data set that we just ingested. Then this is about the training and the testing data set. So what we have used is that we have split the data set and we have used the filtering criteria for that. Similarly, there are different metrics that are present. So how do you want to evaluate your model? So in this case, we will actually be using accuracy to optimize the model. So that is what we are going to choose over here and so on. So features handling, let's go to features. So once we train the models, we know what features are going to be important and what is not going to, or which we do not want to be a part of our testing. So we can select or we can toggle or on or off the features from over here. Coming to the modeling section, this is the algorithms, the different kinds of algorithms, both supervised and non-supervised are present over here. So as you can see, these are the two algorithms which have been selected by default for this particular data set. If you want to try with any other model, you can simply toggle this off and work on this. Now, for this particular data set, so as I mentioned, we already have set the metrics as accuracy because accuracy, why? Because we will be using the accuracy as our parameters to test how well our models perform. Now, once we have set this particular parameter, we can actually click on train the model. So you can see this is the blue button which says train. So you can click on train. Now, simply just these are not the mandatory options. So we will again simply click on train. And as you can see, these two models, the algorithms that we selected, or the logistic regression and the random forest, they have started running. So it will take some time to run and then we will analyze and see the results. Okay, so as you can see, since the data was very small, we had a very small data set consisting of just a few records. So that is why it took, I think, very less time to actually run. And the score or the accuracy score for the logistic regression is 0.96 and with random forest it's 0.98. So definitely logistic regression has a higher accuracy, and so that is why it shows this is the winner of this particular session. So session over here highlights that this is the how many sessions or how many times you want to train the model with different parameters and tweaking around. So now that we have tried with the default features, now let's try and play around and see that how we can change some of the parameters and then see what is the result. So with this, let's go to the algorithms tab again. And for the random forest, how many trees have been defined is already by default present over here by 100. This is basically how many divisions do you want. So let me take another numbers, 200 and 400. And once this is done, so we can keep the other default values as it is. And definitely this is something that you can play around. This is not a very hard and fast rule that this is what we need to choose. This is depending upon the data set and the kind of model that you feel is required according or based on your data set and based on your problem statement. Now, we can try using another model, logistic regression we already tried. So let me add one other, that is XGBoost. And once we have done this, then we can again try and training the models. So let's click on train. Now, as you can see, this is the second session that we are running, and it will take some seconds to run again. And these are the different things that it will highlight over here. That what is how much time did it take to load the training data set? So 0.6 seconds. It's very fast. Then it is at what moment showing what are the steps which are highlighted over here. So we have the first result again, which is logistic regression with 0.996. Accuracy. Okay, it is still running the rest2 model algorithm, so we will wait for that. Okay, so for XGBoost, we got 100% accuracy. Now, in a real world scenario, this is probably uh, very difficult to achieve, but depending, since we chose a very simple data set, is why you are seeing this as 1. Let's see the result of random forest, but I'm sure it's going to be the very same. Yes. So as predicted, the accuracy of random forest has increased from 0.986 to 0.988, and XGBoost seems to be the winner the second time. But depending upon our use case scenario, we can obviously choose any of the algorithms and the results that you are satisfied with. Now, since we know that one seems to be it seems to be nearly perfect kind of training, so we will choose and go ahead with logistic regression. And for that, what you can do is actually, let's click on this. Yeah. So once you click on the report for any of the algorithms chosen, you can see what is the accuracy and what was it trying to predict, which is the feces type in our case, and what are the different classes and so on, other information that is present over here. Now, this is the overall report, and if I want to, let's say, deploy, I choose logistic regression as to be the best model that I'm satisfied with. I can actually go and click on the deployment and model name. Okay, then I want to just go with this name and click on create. Now, please remember that this is your choice of which model you are selecting. Depending upon the problem statement, I would like to iterate again. So that is what we have chosen over here, logistic regression. And now, yeah, so this is our flow, this is how it looks now after deploying a machine learning model on our training data set. Now, definitely there are some steps remaining, which is to test on this particular model, which we will see now in the coming section. So now we have already deployed the model. Now is the time to test how our model is performing on this test data set, which we already created in the earlier section. If you remember, we filtered our labeled prepared data set based on well name, and this is the test data sets for shrimplin well. So we will see how this particular model performs. So you have to select on the on your data set, which is the test data set, and then you have to search for evaluate. So let me scroll down to the bottom, and as you can see over here, this is the evaluate. So evaluate, as the name suggests, this will evaluate how well your model is previously trained model is performing on this data set. So let's click on evaluate. Yeah, so this is going to be the evaluation, and for the model, we have to predict the feces type, which was already we defined. Now, what is the output data set? So you can give any name, but again, we'll keep it intuitive. So keep it prediction data set. And then we want to store the results in the CSV format. So we'll click that and click on create data set. Now, once that has been done, we'll also click on metrics to see the metrics, basically the accuracy and the other scores. So also we will store in the CSV format so that it is easier for us to understand, and click on create data set. Now, once we have defined these two data sets for the output and for the metrics, we can click on create recipe. So once you are here, you have to keep this particular option default settings as it is. Now, default, you can keep it as default. You can try playing around and selecting different options. For example, how do you want to evaluate? Do you want to evaluate on just a few 10, 15 or 10,000 records if the data set is very huge, or you want to select the entire data? Now, since our data is already very small, just consisting of 471 rows, so we would like to evaluate the machine learning model on the entire data set. So we will just go with the default options. There are a few more metrics. Yeah, so this is the metric sections. This tells that these are the metrics that this model will be evaluated upon. So then click on run. So it will take some time to run, and let's wait for the job to be finished. Okay, so job succeeded with warnings. This is probably related to the data set because yeah, as you can see, evaluation set might be too small for reliable performance estimation. Yeah, so it's just giving a warning that your data set is too small to be properly evaluated. So we will ignore the warnings over here and just go back to the flow. And once you're back to the flow, now is the time of results. So let's see how well our model has performed. So this is the Shrimplin wells, and if we go towards the end, we will see what has it predicted. So prediction, as you can see, so these are the predictions, and whether the predictions are correct or not, as you can see for most of them. That is why the logistic regression, the accuracy was high, which was 0.996 approximately. For a few of them, the results are the predictions are wrong, which is why it is written over here as false. And if you try and see that why it is, so the probability of phyloid algal baffle stone, the percentage is approximately 76. But if we scroll over here, then let's see for which does it have the, yeah, so it seems to be the, yeah, so it is basically a packstone grainstone, but our model has predicted it to be a phyloid algal baffle stone, which is false. That is why the prediction was wrong. Otherwise, for most of the records, as you can see, the prediction that the model that it ran on the testing data set, and it predicted it to be the correct facies type. So you can actually play around, explore the different attributes that are present in your data set. For the sake of ease, the facies type is already present over here. So if you want to match, you can see, make a comparison between the prediction. For example, for the prediction for which our prediction is correct. So we can see that for a list of all these data, the prediction is waxstone and the actual facies type is also waxstone, which is why our prediction is correct. Just for a few of them, the model did not predict well. So yeah, so this is how our model performed. And now let's have a look at the metrics that have been evaluated. So yeah, so these are the different ROC curve, what is average precision, recall, and the accuracy. So this is the overall accuracy of our data set, of accuracy of the testing data set on which it ran. So this is also comparatively it's good, and you can try actually making these kinds of or evaluating how your model performed. You can try on the rest two algorithms that we ran, which was XGBoost and the random forest. Since we have selected logistic regression to be the algorithm of choice, so the accuracy on the testing data set was 0.87. You can try it with the other two algorithms and see how well it performs. So now that we have, so if I try and summarize, you can see that this is how an end-to-end workflow, right from importing the data set to splitting the data set, or rather preparing the data and deploying a machine learning model. And this is, of course, a very simple and a classic example that I have chosen for everyone's understanding. And there can be, again, multiple steps that you can tweak and do according to your own requirement. If you're talking about the hackathon, you can choose for any of the data sets that you want to work with. If I want to, let's say, for example, if I want to split my data set, I don't want to use the visual recipe, I can also use any of the code recipes that is present over here. So yeah, that is about the overall end-to-end workflow that we did. So if I once again summarize of what, make a summary of what we did. So first we imported our data set, then we joined both the data sets using the join recipe. We got a jointed data set, and then we prepared the data set by renaming a few columns. There can be, again, multiple preparation steps. For example, replacing the missing values with the default value, or removing the empty columns, and so on. Now, since this data set was very simple, it did not need much of the preparation. Once we got the prepared data set, then we split the data set into training and the testing data based on a formula, which is by well name, where well name was equal to Shrimplin. In the testing data set, we got 471 rows, and for the training data set, the rest of the rows. Then we trained our machine learning model. We used 3 different kinds of algorithms, and for the XGBoost, we got 100% perfect score, which is why for this was just to show you how Our variables, they vary. I chose a logistic regression, which had better accuracy. And then we evaluated the same algorithm on the test data set. And then there also we saw that the predictions were good. The accuracy of the model was around 0.87%. Sorry, it was 0.87. So yeah, so this was about the feces classification. And now I think we will, if you have any questions, probably we can take up that on, or we can move on to the next session, which will be covered by Abhineet sir on LLMs.
Yeah, Nivedita, I think this is quite a heavy, tutorial to absorb for the very first timer. So let's take a 10 minutes break before we start the next session. And in the meantime, I'll request all of you, if you have any question related to this, please feel free to post in the chat box and we'll reply in this 10 minutes break time. So this is 3:50. Let's join back sharp at 4. Yeah. And Abhinit will start the next phase of the presentation there.
Sure. Thank you, Nibamita. Yes.
Let's start now. If you are ready.
Yeah, we can start. Okay. So just let me know once my screen is visible.
Yeah, it's visible.
Okay, so this next session, it would be around large language models, and I will be talking about what large language models are and how can we leverage them in the Dataiku framework that we are aiming to use for this hackathon. So it will be mostly dedicated around that. So hello everyone. So myself, Abhinit Sinha, as I already introduced, I'm a domain data scientist production with Innovation Factory SLB Gurgaon. And yeah, so talking about large language models. So these are like the most hyped or the latest offering in the world of machine learning and AI ML. Uh, we will talk about the agenda for the session. It would be around the overview of large language models, what these are, and what basically goes under the hood in a large language model, and how do we leverage it in data IQ, and what are the different nuances of LLM are. We will also see, I will try to showcase few of the hands-on sessions around use cases of LLM, basically for summarization of text, classification of unstructured data. So these are very common use cases of LLM, which we can try and which will be of use also. I mean, if we choose the such problem statement, so then these can be highly utilized and it will be able to give a good solution also in case we want to try the LLM models or generative AI capabilities of data IQ. So that will be really useful in those cases also. Uh, then I would also briefly touch base on the retrieval-based augmented generative AI, which is the RAG modeling of generative AI. And what's next coming in the next stage of evolution for foundational models? What is the next step? So I will also cover that aspect also. So going ahead with this agenda, large language models. So basically, if we have to understand what large language modeling is, so then we can understand large language model in terms of a AI/ML model, which basically works upon textual data. It takes text as input and it performs different type of tasks. It can be task like classification. So classification is like we also might know in the classical machine learning. Like we run uh, classification tasks or we run classification use cases using traditional methods also like logistic regression, gradient boost. So those who are familiar with data science use cases, so they might be knowing these aspects. So similarly here also LLMs have a very effective use case in case of classification of models. Can also be used to perform tasks like translation and text generation or conversational tasks. So the text generation and conversational type, I think most of us have been using also in terms of usage of Chat GPT or any other conversational agent or model that we have might be using. So this talks about that use case itself. So to understand a large language model, so basically the philosophy behind any LLM is it works upon the next token generation model. So we have suppose a statement like the cat mews and the dog. So if we give this prompt just to a language model, so then its task is going to be predict the next word, or in scientific term we can call it also predicting the next token. So how does it work basically? So a language model, it will give us any prediction. Suppose in this case, it gives the prediction move, but actually we know that it should be afterwards bark. So see here the model is predicting something different. Like the model prediction is different from the label. Label is the actual data that we have already given. So in machine learning terminology, that is called a label. So if there's a mismatch between the prediction and the label, so then that model is tuned. Like there's a feedback loop that goes after this outcome verification, and we see like this updated model parameter will again retrain the language model, and this is a loop that runs to calibrate or redefine the model or fine tune the model. So that is what happens in training of a language model. So if we have to understand it in more detail, so any language model, it trains on each word of the context. It is very computationally high. So that's why organizations spend millions of dollars in training LLM model or foundational models, as we call it. And the training, it has a very high learning curve. So initially, if we are testing or building any language model, initially it is going to be very poor in prediction, and it needs a lot of iteration to get better at prediction. So if we have to see this approach, like if we give a prompt, simple prompt, the greatest lesson in life is to know. So gradually it will come to the right prediction. So that is how a model training generally works in a language model, large language model training. So talking about the evolution of LLMs. So LLMs have been in picture from a quite long time. Around 2018, basic LLM models like those who have worked with textual data and NLP predictions. So they might have seen these kinds of model, word to vec, fast text, ELMO, club. So these were very highly utilized at those time also. And these were kind of state of the art also at that time. So basically, what these models used to do, simple textual identification tasks like identification of user sentiment or giving you about talking about like segmentation of that textual data, dividing into tokens. So those kinds of simple analysis, like these are also called encoder models. Like if we see in this particular visualization, there are three types of model. Like one is encoder only, decoder only, and then there are third branch, which is encoder decoder. What these type of models they do generally is like they just tokenize our data. They any input that we give to them, they would tokenize that and store it into a vector form. And then these don't have much application in decoding of that encoded data. So then there is a second branch of models which are like the decoder only models, which are basically just having the decryption part only. And then there are encoder decoder, which is like bidirectional. They will have both the functionality. So this is how the evolution of the different models have come across the time. Out of these models, some of them are open source, some of them are closed source. Like you can see organizations here. So Google have developed so far 8 open source models and 7 closed models. So similarly, Meta, OpenAI, Hugging Face. So there are different organizations which has come up with different type of language models, and they have different usage. Accordingly, we will see like these each have different use cases. Some of these models are good for code generation. Some of these models are good for context identification. Like they have their different use cases and they have their different context in which they work better. All of them are like basically foundational model, but they have a different stage of evolution and they are good at performing certain tasks. So if we have to talk about language models in more detail, or if we have to understand this, so basically the working background behind any LLM, it excel at like the main function of an LLM, if we have to say, it is to excel at a specific task. So basically, it will work on generating the coherent and the credible contribution of input text. So these input text, as we call it, so these are the prompts that we give to a general foundational model or LLM model, and its output or its task is going to be generate the next continuous, credible, and coherent token. So that's the task of any LLM model. So the LLMs or the large language models in the background, in the training stage, they are trained on very huge amount of data. Like these sources of data, they come from very diverse sources. They can come from books, they can come from open websites, articles, and that that's what goes in the process of creating an LLM model. So through this process, the model gets the capability to predict and assist with a different number of tasks. Like it gets particularly uh, so to say, it will get particularly adept at predicting the natural language task. So that's the foundation of LLM. Like it is always going to be uh, very much effective in doing any language task. That's how it trains and that's how it understands. Under the hood, we can then utilize it for other contexts also, like code generation or logical understanding. But the thing that it is going to be most effective at, it's the natural language task, and it forms the basis of its other capabilities also. So if you see in the example, this one, like if you want to build a ship, so if you this, if we just provide this context to a model, so this is going to the prompt, and then it is able to generate the response. This is what we'll call the LLM response. So that's the prompt and response relationship in a LLM model. Now, yeah. So, how effectively an end user can use a LLM model? So, if we suppose get our hands on a very robustly trained foundational model, so now it is up to the user, like how effectively one can use it. So, the usage effectiveness of an LLM, it will be shown only if we have the ability to craft the prompt. Then only it will be, because that's the only input that is going to the model from the user side, and that is going to convey the entire intent of the user, like what the user wants to achieve and how the model is effectively able to deliver that. So that all depends on the craft prompting. So that's what we call the prompt engineering also. So that is the crucial task that we have to understand before going into the usage of LLMs. So now, suppose if you want to task LLM, we have an LLM, and now we want to test it, and now we want to apply it to a. So here only we are seeing one use case of an LLM. We want to understand from the product review, like if we give it the textual data, if we give it a number of product reviews, and we want it to classify it against positive, negative, or neutral. So this is a common example that we can talk about here. So if we task an LLM with this particular job, so what it will do, it will insert, like it will uh, the objective that the LLM is going to do, it like has to we have to give this prompt to the LLM, like decide whether the sentiment of the product review is positive, negative, or neutral. So what the product, so the model will take into account the product review, and it will give us a sentiment. So from the prompt itself, the intent that the user wants is very clear. Like we wanted to give the sentiment. So that's why it has given us the correct response. And in, under the hood, like what it will be using for such use cases of a classification task, we call it a zero shot learning. So if it is it will use in the context zero shot learning for a classification task. So that's going to happen under the hood, and the way the model is going to understand what you want is from through the prompt only. So that's why like it is very much crucial. We engineer our prompt correctly, and we provide the uh, correct inputs in the prompt so that the model can understand what the usage is going to be like. So diving further deep into the hood of large language models, so uh, we can classify or we can break down the working of an LLM under this category. Like there is going to be the first the input from the user. We are going to provide it a input text. Then what the model is going to do. So, and of course, we are not going to see all of this in action. We just see the result. But to understand what is happening in the usage of an LLM, it is going to tokenize. So basically, it breaks down whatever context you provide to a model, large language model. That textual in prompt, it is going to break down into a number of sequence. Like it is going to break it down into different token sets, and that token sets. So you often would be hearing also, like you are using a LLM, like you are using ChatGPT only. So the difference between the ChatGPT free model and the pro model is how many tokens you can consume. So that's the difference. Like that's where does that token come from? It comes from here only. So whatever input text that you provided, it breaks it down into tokens, and the larger or the complex your input is going to be, the higher number of token it is going to make. And then the model is going to receive as input higher number of tokens. And that's where like the if you have on a free model, so you can give less tokens to a LLM. If you are on a premium model, so you can give high numbers to a token. So that's how the tokenization works in the backend. And now once you have broken down your input into tokens, now the language model, it understands those tokens. Like it is not going to understand any normal language, it understands the token. So it will input those tokenized documents, and then in within that language model, it will have now build a decoding strategy. So what we discussed earlier about the encoder and the decoder. So here what we are it is doing, it is now going to decode that token, and it is now going to generate probability matrix inside the prediction pipeline, and then it is going to see what's the next token, like based on the tokenization and the decoding, it is now going to give you the next token for the prediction. So that's how it works. And to understand this tokenization part, I can show you one example also. Yeah. So there is an open AI platform where you can test your tokens. So this is from the OpenAI platform. And here, if you have to understand the tokens, so you can understand, like if we give it a simple textual input, like today the weather is very hot. So it is a simple enough prompt given by the user. So you can see here the tokens that it generates for the total 29 characters is just 6. So it is fine, like it is not generating very high number of tokens. But suppose if we add more complexity to it, so like can you read this document and provide the balance sheet information or something like that? Like the more complex your balance sheet information of last quarter. So it is still simple, but it has grown in complexity from the last one. So now you see the tokens, it is generating 17 tokens now. So you can play around with this tokenizer, like OpenAI platform has it available for everyone. And for different models, the tokenization is different. In this case, it is all coming up to be same, but it is different. Like if we have to click here, so like see this prompt, it is complex enough. So this is now generating 53 tokens. So that's how we understand the large language models. How does it work in the backend? So that was about how it works under the hood. So moving on to next one. Now, yeah. So moving on further into the details of the large language models. So tokenizing input text. So before being processed by a language model, like what we already discussed, that textual information, it will be broken down into sequence of tokens, which will be like a array of words of the words, and then these tokens are like it has these are selected among a set of predetermined set of potential tokens, and then they can be broken down into binary format. Like this will be broken down into zeros and ones, and the matrix will be forming. And we already saw this OpenAI website where we can test our prompts and tokens. So now once we have tokenized the input text, the next step in estimating the next probability. So what it does is like the language model, it is now going to take as an input the sequence of tokens, and it is going to return the you might have heard this word in before, probability distribution. So those who have not heard it, like it is um, when we run estimation of any parameter. So we generate not just the single probability, we generate the probability distribution over the complete sample space. So that's where this probability distribution comes into picture. Like it is for understanding the uh, uh, sample distribution space that the parameter is going to have. So the model also in the backend for the next token, it generates a probability distribution of the samples. And then what the model is going to predict as the next token. So that has different ways, like different models either give it the most probable token, it will give you that, or it will give you the within that sampling space, it will give you the highest token, like the token with the highest probability density, it will give you probably that. So that's how basically the next token prediction works in LLM. So yeah, so talking a little bit more about the decoding strategy. So what I was talking earlier, the probability distribution over the next token can be used to understand the continue the input sequence. Like it can either have two strategies. It can either be a gradient decoding strategy, which means like the token with the highest estimated likelihood. It is going to predict that as the next token. Or then otherwise what it can do is like it can generate a probability distribution over a sampling space, and based on that it will generate the next token or the next prediction. So that's how basically the decoding strategy or decoding part of the language model works. So now we will take a look into the Dataiku usage of LLMs. So till this point, like, is it clear, or is anyone having any question? So I can answer that. But is the part of LLM where the basics and the foundation, um, is it okay with everyone, or do you want to uh, assess further on any aspect? Okay, so then moving forward. So how does Dataiku enable the usage of LLMs? We already saw the platform for AI, right? Dataiku, which is a robust platform for using the different AI and ML features. So this platform has now uh, come up with a way to enable usage of LLMs also on this platform. Like we don't have to go anywhere else for specifically LLM uses. We can on the platform itself use LLMs very effectively, and on top of it, it also provides various additional functionalities which are enabling for the enterprise as well as the single user also. So it is highly capable and robust in that sense also. So when we talk of usage of generative AI, so there are a couple of barriers or a couple of entry barriers that are there that anyone faces who is new to usage of generative AI and who wants to use this in their day-to-day role or into uh, enabling or more improving their workflows. So they face numerous challenges. One of them is that they don't have enough building knowledge of how to use this generative AI. Then there are other challenges also, privacy, security, compliance. So these are generally with any organization. We face this issue also in usage of generative AI. And then there's need of governance also. So even if we want to use generative AI or large language models at enterprise level, so how do we monitor the usage? How do we enable governance? How do we ensure compliance? So those are also uh, quite common challenges in scaling of or in implementation of uh, language models into enterprise AI or into day-to-day usage AI also. So Dataiku has the solution or has the product capability to ensure that also. Then the Gen AI landscape is very agile, or is to say that it is very dynamic environment. Every couple of months, you might be hearing of some new development, some new model coming in. So to keep track with that, or to avoid any lock-in situation in such cases where we are not locked in with a particular AI service, or where we are not able to use any upcoming new feature. So that freedom from choice and dependency. So that is also very much coherent in Dataiku. And we can see like we can use different AI service providers, different LLM models, and we can compare their usage, and we can also provide further details or insights into it. Cost control is also something we struggle with when it comes to GenAI use cases, like we saw earlier, the token usage, and uh, how do we ensure that we are not overrunning our model cost by giving a very unexceptionally large prompt. So those things, those controls, we can easily implement through usage of Dataiku. So those features are there, which make it ideal for enterprise AI and usage in day-to-day and implementation of LLM model workflows. So the key differentiators of GenAI on Dataiku is like it makes it very easy to use. We have no code plus low code solutions that we can implement like traditional data recipes or traditional code recipes. So we can implement these easily in Dataiku. We have made it easy to use the security and control features. I mean the governance, the audit, and the cost-aware framework. So that is again a very reduced risk in Dataiku, and it is also available as shared service, which can be utilized across multiple functions. So those are the premium features that GenAI on Dataiku offers. Then we have the choice of agility also. We avoid any lock-ins. We can use multiple LLMs. We can use multiple AI service providers. So those things provide a very agile environment and a very flexible environment to use GenAI and Dataiku. And then again, we have a holistic platform that comes with Dataiku. We can use traditional models, we can use deep learning models, and we can augment our workflows with usage of this GenAI on Dataiku also. So these are like the differentiators, the key differentiators which the Dataiku provides on enterprise AI. Now, coming to the question of how actually the LLM is going to work on a platform like Dataiku. So, as we all know, like LLM is a generative AI application, and it falls something in between to a no-code, low-code environment to a full-code environment. So you see here, like how an LLM is integrated inside a Gen AI model is like in Dataiku is the usage of this LLM mesh. Like the functionality of generative AI in Dataiku is what we call LLM mesh. So this LLM mesh now becomes the backbone of Gen AI applications in Dataiku. And what we mean by LLM mesh is that it is an umbrella of all the different Gen AI functionalities that we have in Dataiku. We can talk about routing and orchestrations. So this is like more anyone who has done any work on development or software engineering, so they might be aware like we have to orchestrate our workflows, we have to route them to correct scheduling frameworks. So LLM mesh is the umbrella which caters to all these different modules of software lifecycle development. Like we can take care of our routing and orchestration, we can take care of cost reporting and accounting. We can take care of security and IP protection, things like PII detection and content moderation. We can have an audit trail to assign and verify different aspects of compliance and governance. We can have different security features, caching features, retrieval augmentation. Like this is again a Gen AI feature which we call RAG. So this is also possible in Dataiku. So all these combined under one umbrella is what we call LLM mesh in Dataiku. And the different functionalities that we get through usage of Gen AI in Dataiku is like we are free to use GPUs in Dataiku that we will be able to. Those are decoupled service. Like it does not inherently come with GPU, but we can enable the usage of GPU. So any type of accelerated hardware requirement that we want, so that can be achieved via the platform itself. Then we can host different LLM API service providers in Dataiku. We can use Azure service, we can use OpenAI service, we can use AWS or Google, any services we want. And then apart from that, we can also use self-hosted LLMs also. So you might be aware of different Hugging Face models or Llama models. So those are like completely on-prem models. So we can use those self-hosted LLMs also on Dataiku, and then we are also free to use any type of vector stores. So vector stores, those who might be having some knowledge into Gen AI. So these are like very tailored databases for LLM predictions or LLM results. So we are open to use any type of vector stores also in Dataiku. So all these combined together in Dataiku is what we call LLM mesh. And its premium features are like it decouples the application and the service layer. It ensures the security gateway, and it ensures safe usage by the different IP protection features like PII detection or content moderation. It obviously controls the cost of usage, and it also helps us in engineering our prompts very better way, like through enriched query mechanism or built-in RAG modelings. So it provides all these premium features when it comes to usage of LLMs on Dataiku. So diving a little deeper into the LLMS background or the functionalities. So what it basically does, so if you see here, like we saw code recipes earlier, so similarly we have no code Gen AI recipes also on Dataiku. Like if we have to run a classification task using an LLM model, so we can run a classification recipe also for that. There are prompt engineering studios also that are available in Dataiku, and you can use them in your workflows also. And this will allow you to use different models, be it Anthropic model, be it GPT model, any model that we want to use. So all that is possible through that prompt studio. And then we have different AI services that we can use via LLMs. So all these are available under the usage of LLMs in Dataiku. And uh, yeah, and we also get the functionality to test different services. We can get idea about the costing. We can get idea about the performance of different AI running on top of LLMs. So all those comparative and inclusive features. So those are available with the usage of LLM Mesh on Dataiku. Digging a little deeper, so what actually it does in the backend. So we can in the inside Dataiku, we can centrally manage all our access keys and credentials for different service providers. So there is a central repository for that that is available in Dataiku. Through that we can maintain our API user fee credentials, and for all the different service providers we can securely maintain our repository of credentials and access keys there also in Dataiku, and we can easily switch amongst them also. And then Dataiku, when we are using LLM through Dataiku, it also gives us the functionality to log all the queries and give the request, like since we are going to be using multiple service providers and we are going to create a auditable trail for the usage. So then in that case, we'd also want to know the different logs and the different service requests that are being raised in the backend. So for that also, it has and it captures those logging level details also when we are using it on Dataiku. As we talked about before also, like cost monitoring and proper resource utilization in terms of memory management and caching. So those type of optimization strategies like efficient memory management and efficient compute usage. So that those features are also enabled through the usage of Dataiku monitoring dashboards, which can be implemented. We can see the scale of usage of our resources. We can see the memory management and the resource utilization that is consuming. So all that is also possible, and we can do a comparative study between different services also. So the next slide talks about the retrieval augmented Gen AI, which is basically the RAG model. But I'm not sure. Do we want to pause for any clarification, or do we want to take a break? It's, I think, half an hour only into we started. So should we continue, or do we have any questions?
How long the next phase is gonna take approximately?
I have around 30 minutes or 20 to 30 minutes of slides, and then a quick demo of the LLMs on Dataiku. So total, it should take roughly 45 to 45 minutes for me.
Okay. So let's continue, yeah? Maybe we can take a break before the demo.
Okay, so we have seen, yeah, we were talking about retrieval augmented generation. So, yeah, so there's a concept in that is the next level of usage of foundational models. So foundational models basically are trained on the publicly available domain, like publicly available data, right? We saw earlier, like any type of foundational model or language model. So it is going to be trained on uh, data which is publicly available either through books or through any context, like be it websites or be it some database storage, enterprise storage. So any type of foundational model is going to be trained on that. Now, the next level of evolution in any language model is the usage of specific curated data. So if any foundational model we have trained, be it like, let's say we talk about uh, chat GPT model, GPT-4o. So that model is going to be having information about all the global context. It is going to have information about all the world, so to say. But if we want to use that model for our use case, so then that is quite possible that that model does not give us good answers or result if we are going to use it for our particular use case, or for, say, if you want to do it for any geophysical study or any faces interpretation study or any seismic study. So then obviously that model is going to predict the next token based on the input that we get it, but it is not going to be that effective in that context because it has not trained on that one. It has not seen that information, and on which it has not seen, it cannot say with better accuracy. So to solve this problem, this next step in LLMs comes into picture, where we augment that model with some retrieval information. So that retrieval that we are asking from the model, it is augmented by some context information. So that is what we call RAG, retrieval augmented generation. So any information that we want to give to a already trained foundational model, so that we provide, like that we provide to a model, like this is our context information, and that we are giving it via embedding. So basically what this will do, this recipe is going to embed information from this context information, and it is going to create one vector DB for us, which the model can now query easily. So our LLM model now has all the global information plus this specific context information also. And now its response is going to be very much accurate for our use case, because it has taken into account the specific information also, which we want to learn. So that's basically what we call it, retrieval augmented generation. And it is very easy. It is also capable, not very easy, but like through some configuration, we can do it in Dataiku also. So we can see typical examples of this, like we want to work from a knowledge band. So any type of documents that we have, we can simply store them in a directory or folder structure, and then we can implement typical textual information recovery processes like OCR. I think most of us might be knowing this. OCR is optical character recognition. So any image or any PDFs or any type of such image from where we want to extract textual information via understanding of language processing. So there we implement OCR methods, and then we can other things, like if it is in a different language, then we first implement OCR, then implement translation on it. So then we first create a database bank, and then we select the model of our choice for creating the embeddings. Embeddings is like the same, we can understand it as vector DB. So we can select any foundational model of our choice, and then we can create embeddings from that model. And then once the model has it, then it will process it and create a knowledge bank or a vector store. And then then it will use that augmented model along with the context information to give us very accurate responses. So that's what we call the RAG implementation. So now that we have seen about usage of different type of text-based prompt, we have seen usage of retrieval augmented prompts. So now one by one we'll see what are the different use cases that we can uh, think of for usage of LLMs, and what the participants can also try at their level that would enhance their workflows on different type of language models. So first case is like the simple case of LLMs. What everyone generally uses LLMs for is like for common language tasks. So we can use these capabilities of LLMs for common language tasks of LLMs. We can utilize off the shelf, like there are different visual components that are available in Dataiku. Like we can create our prompt through this prompt recipe. We can classify text based on this classified text recipe. We can ask it to summarize our text for us via this summarized text. So these are all no code recipes for GenAI use case in Dataiku, and we can utilize these no code for simple language detection tasks or language tasks to understand and to get our kind of results. Like it can work on use cases like we want to extract entities, we want to do text classification, text summarization, translation. So those kinds of common language tasks which are highly useful for any use case, we can utilize them, and we can use them in the workflows. So this is one of the use cases. Then we can do prompt engineering in Dataiku. So we have customized LLM output, like, and we can refine the prompt context. So they, like as you can see in the diagram, there is a proper prompt studio that is available in Dataiku, and through that we can engineer or craft a prompt very effectively. Like we can give them inputs, we can extract information out, like we can make it a little bit more structured, and then we can make it a text response, we can make it a structured prompt. So all these things we can do it. We can save as a prompt recipe. We can estimate, yeah. So how many uh, tokens it is going to generate from that prompt. So that kind of performance analysis we can also do in that uh, estimation and comparing scenario also. We can validate our model responses also. So all these are possible via the prompt studio that is available in Dataiku, and we can make that prompt like the prompt that we generate out of the engineering and the prompt studio in Dataiku. We can make it model agnostic. Like we are not necessary like one prompt that is we are going to generate through the prompt studio. So it is only working for a one particular model. We can make it effective for all the models also. So that way we can make it model agnostic in the studio. We can see relative performances, and we can do validation also. So these are all the things that are possible if we want to do that engineering level of prompt engineering in Dataiku. So that is very well possible through that prompt studio in Dataiku. That is the next use case that we can try. The third use case that we can try that we already talked about is for your particular problem statement or for problem that you want to sort of address through this initiative, like creation of a knowledge bank or creation of an additional context that you want to give. So that kind of functionality of information retrieval and augmenting any foundational model to build any like Q&A apps or chatbots that you plan to build. So that is also possible in Dataiku. You can build a question and answering chatbot type of application using RAG enhanced LLM model. You can usage from the RAG model, you can do text extraction from files. You can embed your models. You can do create vector stores for your already trained for already extracted data for already what you call it, embedding from where you have already done the text embedding. You can create vector stores out of it so that the responses, the pipeline that you create is made effective by it. So all those things that can be possible and that you can think of as a use case for creating your LLM solution. Now, coming to few advanced techniques that you can also try. You all must have heard about agentic frameworks that are now coming up, and we have LLM agents. These agents can just not just get information or predict the outcome for you. It can also take the action for you. So those kinds of LLM agents also you can build, for orchestrating your reasoning task or for creating chain of points, those type of things. So that type of agentic application of language models, that is also possible, and that you can think along those lines also. Uh, you can also fine tune your own models, like you have created through traditional AI or you have created through deep learning AI. So for fine tuning those traditional models also, you can try that LLM agents that can help you with fine tuning those models. So these are the different things that are possible, and those advanced techniques, LLM techniques, you can also think for your workflows for making it more robust. So these things you can keep in mind while trying your different use cases for LLMs. So now I would show you a quick demo of how the LLM framework will look in Dataiku. So since we have said like we want to continue, I'm continuing this hands-on session also without a break, but let me know if you want to take a break also. So this is like a common workflow that we can try for usage of LLMs. So what basically the problem that we are handling in this workflow, we have a data set. So this is a data set of all the news articles. Like it is compiled from different sources. So if you see here, let me zoom in. So if you want to see, like this is a complete news article in each of the rows. And this complete news article with which date it was published on, what was the headline for this news article, and which news category we wanted it is referring to. So all that information we have. Now we want to do different tasks or different insights on with this information. So this, as you can see, this is all unstructured information. Like some of these articles are too long, some of these articles are short, and then there are different type of news categories. So it is like either related to sports or business. So there are different information here. Now we somehow want to utilize this and make it more searchable or more indexed via use of LLMs, right? So we already have seen the functionalities of Dataiku, like we can use these no-code, low-code recipes, like for first massaging our data, for preparing our data, like we want to filter out few things. Suppose we want to create a column article length, like which tracks how much is the length of that article. We want to pass any date information. We want to compute difference between dates. Other things that we want to do, it's like just an example. We want to replace something, like there is some information that we don't like these are common things that we have to tackle, that we have to do when we are working with such a exercise. Like we want to replace something, we want to find and replace something, we want to extract few information, we want to uh, trim our data, we want to we can be like there can be different different things that you can think of. There are different any data that we get in a data science problem, cleaning the data is the major challenge. So here that's what we are doing, like the usage of this uh, no code low code recipes. We are first cleaning our data and then preparing it. So we have to perform some joins, or we have to add some index. So all those things we are doing here. So now once the data is in a better shape, like if you see here, like here, yeah, the data is better structured. We have extracted the city information out of it. We have extracted the article length out of it, and we have extracted the uh, like row number, which in which row number of the article we can find this information. So once we have extracted all those relevant information and prepared or made the data ready, so the next step is now we will run our LLM recipes on top of it. So as you can see on the filtered and the prepared data set, which is called the article test filter, we are first running one classification prompt. So now we are using one GPT 3.5 model, and then we are input column article. And this from this column, we wanted to classify in these categories, whether in business it talks about the economy or it talks about the politics, whether in sports it talks about the baseball sports or it talks about the athletics kind of sport. So we have given it these four classes, and now we will ask our language model to give us this recipe or to tell us this based on the article column, based on this column. So now we just hit run. So in the backend, it is now going to run the language model. It might take some time. Okay, I started. So it is in the backend. It is going to call the API. It is going to fetch response from it. It is going to pass the response, and it has completed. So if we now see, yeah. So yeah, now we have this data set, and now we have the prediction. So now the model is saying, okay, this article which you gave me, it is now talking about business economy. It is talking about economy. So this way it can work, the LLM model, and that's how basically the LLM predictions work. And why it has given it this response, like it is talking about business and economics, so that we can understand. So for that, it has also given an explanation. So why it has given us the context, like it is talking business. So the LLM says it is predicting in this class because the text discusses oil prices, global supply glut, and oil production levels. So that it has also given the reasoning behind this prediction. So you can see how we are utilizing the complete potential of LLM through Dataiku. So if the so in this case, all our API calls to the LLM, so those were all successful. It had occurred any error or it had occurred any response code which is not success message, so then it would have captured those. I think in some cases there was some error, so that's why it has given, yeah. So these cases it has also returned like there was a issue and there was some issue, so it has captured those raw responses also, error messages also. So all these can be done directly in Dataiku. We can use different LLMs. Like if we have to see, there are options to use different types of AI models that we want to use. We can use GPT 4.1, 4.2, RAG models, and then we can. The main advantage that I see is like we can do it for a large number of data set also. So see here, we in a time of 2 to 3 minutes, we have passed how many rows? We have passed 88 articles we have passed in just 2 or 3 minutes. So this is like huge advantage. If we have gone to do it manually, so then it would have taken like a lot of time. So it has processed that many amount of data. So similarly, like if we want to also do some sentiment analysis on this data, uh, like we want to identify what emotion it is talking about. So then we give it the task of emotion analysis, and it will also run in that case, and it will give us the sentiment of that context also. So here, if you see, it is talking something neutral. It is talking something optimism. It is talking of disapproval, optimism. So all this from the context, it is able to give us. So these are like different type of no code, low code things with Gen AI recipes that we can do in Dataiku. And apart from that, if we want to just get a summary of the different articles, so there's a recipe for that also, which is called the summary recipe. So it will just give you a summary of the complete article, like what is what talking about. So if you see for this article, which was like this one, it is talking about some airline crash in Karachi. So just one line summary of that. So that is also given by the LLM also here. So these type of classification or text classification tasks, we can ask our LLM to perform for us. Then we curate our data a little bit more, and then we can do question answering things with also with our LLMs. So suppose there are two scenarios here. One where we don't give the context. So we initially here we came with some input, some amount of input data, like 88 articles we started with, and uh, we can ask questions, different questions to our model, like these type of questions. What are the majority of articles about? Name three topics. What top three sports events took place in last 10 years? So we can ask these questions. So the thing is that like the model can answer them on its own also, like it will going to answer, like if you do not give it any context, and if you ask a GPT 3.5 model to give answer these questions, so it will answer, like it will answer without rag. It will give you the answer of these questions, but these answers, it was not going to be accurate for your case, because it is like when you are asking what are the majority of articles about, name three topics, so it is giving you the answer. The majority of articles are about current events, technology, and health. So it is not just talking about those 88 news articles that we gave it. It is talking about globally how many articles it has found, and it is giving you that answer. So this is without rag. Like the LLM can give you answers without rag also, but what once we do the article embedding and answer it with like give it the context also, so then the answers that it gives now, so then it will be more accurate. So whatever question you ask it now, there's some error in this recipe, it has not run it, but it whatever response it is going to give you now for this question, so that will be about those 88 articles that you gave it initially. So that's the difference. Like we can run it with RAG, but it is recommended you do it with RAG. Like you make a context, you implement RAG, and then get your responses. So that's the difference when you run it with and without RAG. So I think, yeah, so that was the hands-on. I don't have anything else in my session. So, that's it for the LLM session. Nikhil, over to you. Or Namamita. Any one of you can take over. Hello. Hello, am I audible?
Yes, yeah, Abhinit sir, you are audible.
Okay, okay, okay. So yeah, that was it about the trading session on Dataiku. If you have any question, you can unmute yourself and ask.
Unmute कर सकते.
It would be better if you can put your questions in the chat. We will answer them one by one.
Yeah, okay.
So there is one more use case which Ayush Agarwal sir will be presenting. Abhinit sir, can we start?
Yeah, I can.
Iskandar, Shivam Pashan is there. I think he raised his hand, I think.
Yes,
Mr.
Yes.
Shivam, you want to
Shivam
say
can.
something?
Probably you can put your questions on the chat, Shivam, if it is okay for you. Yeah.
Okay, I will answer that question. Ayush sir, you can start uh, one more demonstration.
Okay, so I'm just sharing my screen. Vishwendra, can you confirm if you can see?
Yes, sir, I can see your
Okay,
screen.
perfect. So I think today you almost have a better understanding of Dataiku now, which you had probably before joining this session, on how to do some basic data engineering workflows, as well as create machine learning models, and also use generative AI um, and other LLM based applications in this one, right? So what now I wanted to show you further is another use case, or how you can use generative AI in your proposals, in your ideas, which you will be doing with this data set. So most likely you can expect some kind of a seismic with a well log and some reports for this hackathon. So in terms of, for example, for seismic data, basically these are SegWi files. So what you need to do is you will first need to read those and convert those into NumPy arrays, and then read those into Dataiku. You cannot directly work with SegWi files on Dataiku, but well logs, etc., are simple Excel type formats which you can directly be able to load as a data set, right? For example, if you see in the file system, upload files, you'll be able to do it here, right? So, but for example, I want to show you a use case where you have multiple reports, right? So you can be expecting some geophysical reports or well-related reports, etc. But for example, all the reports, what you can do is you can upload as something as a managed folder. So you can create, if you go here, you can use a file system. You can add a folder here and start uploading data sets in it or files in it. So basically, if you see, this is an example, an open source data set, a daily drilling report of geothermal, organization, and what if you want to do is you want to extract certain key informations from this report, or basically try to summarize this. You can make use of the LLMs and other visual as well as plugin recipes available within Dataiku. For example, a use case in this flow zone, which you can see. So don't get confused about these separate boxes. These are just like making it cleaner for you to understand. So these are basically zones. You can add a new zone, like for example, test, confirm. So it will create a new zone, and you can start creating some recipes here, and basically segregate accordingly. So for example, here what I'm doing is we have a bunch of reports I've uploaded here. Now what I want to do is I want to first extract information from these reports, right? So if you click on this folder with all these reports, you will see a plugin recipe called text extraction, which is already there. So it has some capabilities like basic text extraction from conventional PDFs. If those PDFs are scanned documents, you can run an OCR, some grayscale images, image processing. So because these are conventional PDFs with me, I can do a basic text extraction, run this, and I will get the file name and the entire text extracted here. You can see if I hover over here, I can see the entire full file is passed as the textual document, right? So once we have this text OCR reports, now what you can do is you can do multiple things. Maybe you want to extract certain informations, you want to summarize it, classify it, etc. So here, if I click on this one, we can see that there's AI LLM recipes. You'll see a lot of LLM recipes here: classified text, prompt, summarize text, embed text, etc. So the definition, I think all of these Abhinit are explained to you in the previous presentations. So if you click on the prompt, what you can see is you can select the LLM from here. You'll be getting an access to the LLM from us, uh, probably with limited tokens though, but it will be sufficient for your use case. And then you can write a prompt. For example, here I'm writing that extract well ID, report number, report date, operators, all these informations I'm asking the LLM to extract from those PDF reports, right? And then I tell them that you need to you can find this in the column text in my input data set, and then some basic settings, temperature, etc. determines how much your model is hallucinating. So 0 is the best number to use so that your model doesn't hallucinate at all. Whatever is there in the data, you get the same response. It doesn't generate itself, or it doesn't become very creative. Uh, so once I do this, what it does is whatever information I've asked it to extract, right? So if you see, if I hover this one, you'll see it has created a JSON, like a key value pair, well ID, report number, etc. So it has gone through the entire text and identified these key informations. So this is from a drilling report. Maybe if you get a seismic processing report, you might ask some other kind of informations to be extracted from there, right? Maybe the coordinates, etc. If something is useful, you want to integrate your well log with seismic in any use case, then so once done, you can then use a prepare or other recipes, which Nivedita I think already talked about, to do a lot of other things, right? So what we did is we kind of unnest this object. So like you can see, this is a nested JSON file, right? LLM. It has, yeah. So now what you, if I unnest this, it will create each key value pair is extracted as a separate column here. So you will then have a proper Excel type data set to work on. So your unstructured data is now being successfully converted into a structured data set. And then there can be multiple use cases. For example, if someone is trying to create a chatbot, we'll follow a RAG based approach. But if you just want to summarize things, for example, I just take this and I'm using this AI prompt here. What I want to do, I'm asking a question is, what is the measured depth of the well? Right. Similarly, this is another um, basically this is a RAG based setting when I'm trying to create an embedding model. But probably the chatbot kind of thing, I'm not sure if that would be a proper use case in your proposal, uh, because that would require a consumption of a lot of tokens. Then you can see the final report generation based on the questions you have asked, and then you can do a lot of other things. Basically, this is what I wanted to show. So um, so once you have uploaded a data set, you can do a lot of things directly visually only, like using all these recipes, etc., which is there. And if you find it difficult to use these, and if you're comfortable using Python or R, what you can do is you can directly I mean, remove using or skip using these inbuilt recipes and directly maybe add a Python recipe. Like I want to extract text by myself using some library called PyPDF or something that can help you create that. And if I just maybe create a file system based CSV this, so it will create a starter Python code for you. And then what it does is this data reports info now has the file wise data. So now you can start writing for each file, F in this, do this, right? So you can also write manual codes instead of using recipes if you find it difficult, because I know it can be overwhelming to see a lot of different new stuff in this Dataiku, though easy. And another tip from my side might be that Dataiku, because a lot of it is open source, a lot of information, documentation you can find online. You can also take help from ChatGPT or other AI assistant tools available to ask queries on ChatGPT, and it gives you fairly right answers. You can ask them to think and suggest recipes for you, what you can use, even generate some Python code. That's completely fine. I mean, what we value is what idea you are bringing on the table and how much data IQ you can use, right? So this is all I have. If you have other questions, you can feel free to type in the chat. And I think Vishwendra will also be sharing some further conversations on. We can have some query sessions starting once we kickstart this officially. Uh, so we can further discuss and address your queries if you have in the meantime. So yeah, if you have any questions. So yeah, you will be getting the data set on the platform itself in the Dataiku project, from where you will be able to download it.
Hello everyone. Uh, am I audible?
Yes, Vishwendra.
Okay. So I have onboarded like around most of you on the Delphi platform. If you will be able to uh, open this link, I will put it in the chat. Yeah, so you have to basically to answer the question Viresh has asked in the chat. Uh, we will provide you the data set, and you have to identify a problem statement on your own, and then you have to build a prototype using AI to solve that problem. But the data set remains the same. All of you will be working on a common data set, and I have given you a theme: seismic, well logs, processing, and interpretation. No seismic processing. The note is you do not do anything in the seismic processing; it will be rejected. So you can do seismic interpretation, well logs processing and interpretation, insight generation, or anything. So that is the theme using AI. So you have to solve some subsurface problem uh, with the use of AI. So that is the theme. But you have to work on the dataset which we will be providing, no any other external dataset. So uh, just a second. So if you open this link which I have put in the chat, I believe you will be redirected. I will just share my screen. Yes. Can you see my screen?
Yes.
Yes.
So if you click on the link which I have provided, you will be redirected to this Delphi portal, and you will be seeing some of the solutions here and some trainings here or something. So if you are, I have onboarded most probably all of you. If you find any difficulty in accessing this page, let us know via the WhatsApp group. I will onboard you. So what you have to do once you are on this page, you go to the solution, you click on the Lumi. Lumi is our AI integrated platform. Then you go to this data science. This is already been approved for most of you. Once you launch it, you will be redirected to another page. Oh, just a second. So anyways, I will provide you this link. You can directly access the data IO via this. But if you click on the launch, you will be redirected to this page. This page is down maybe right now, but I will provide you with the link of the data, and you will be redirected to this hackathon dataset. So this is the hacker dataset which you will be working on. It has three things. We have a petrol project, and we have in the petrol project there is this zipped file which has the petrol project and the terms of data uses. This is a very important thing. I want all of you to go through this before accessing the data. You have to read this carefully, because if you violate any of the data uses terms, there will be disqualification. And so this is one of the petrol project dataset of the field. And then this is raw data. Here also you will find the terms of usage and the raw data which you can download. So raw data is basically the exported data from the petrol. Basically you will find seismic sections, 2D lines, 3D lines, 3D cube, well logs, headers, deviation data, horizon, fault sticks, fault polygon, everything you will find in this raw data. And then there is this reports. Here also there is a terms of data uses. You have to read it very carefully. Then there is the link for the reports and the documents. So it's an open source dataset which you can access. The link is here. So this will be the dataset that these three datasets are the common dataset which you will be using to build your to train your AI models or to identify the problem statement. So after some time, you will get the access of this project. Right now, you won't have the access. You will, however, you are onboarded on the Delphi portal. I will share you the link of this project, and after some time, you will be able to access it. So this is the dataset. Now, the thing is that you have to build your own project. Like if you click on the new project, blank project. So the name of the project which you should give will be same as your team ID, which you have been provided when you have registered the on the SPG portal. So your team name will be your project name. Team ID will be the project name. I want this to be very clear. Team ID will be the project name. Any other uh, name of the project will be deleted. And if we find like two project for the same ID, it will also be deleted. So if you are two people in a team, then you will have a single project and your project name will be your team ID. So this I wanted to uh, focus on. I believe it is clear. If you have any questions, please put it in the chat right now. So yeah, access denied in the data science page is because maybe it is down right now. Uh, after some time it will be open, but I will provide you with the link and via mail along with the instructions on how to access the data. So I think we are clear on the data part. The same project can be accessed, edited by both the team members. We need to create only, yes. So you can create a project and you can add your collaborators into the project. So like 3 people, 4 people, 5 people, whatever is there. If you have one team, one project, and 4-5 members can work on a single project. And also regarding the Gen AI and the LLMs, we are planning to provide the API keys to all of you, but there will be a limited uh, tokens or limited credits for those LLMs, and you need to follow some of the guidelines which I will be sharing before using those API keys because of the security reasons. But it will take some time. For the time being, I advise you to do any of your Gen AI stuff outside of the Dataiku. But soon you will be conveyed via email regarding the API keys and the access to the LLMs. Yeah.
Vishwinder, can we open for QA session now, like formally?
Yes. So let me.
So team will be unmuting you all probably. That's how we wanted to do and see. But let's take question one by one, yeah. And just to be sure that we'll take everyone's question. So yeah, if you have a question, raise your hand. We'll take your name and then you can throw your question here. Yeah.
So yeah, your mic is you can access the mic now. You can unmute yourself and we can have uh, any question, any discussion, whatever you want right now. Okay, Abhinav Raj. Please go ahead. You can unmute your mic.
Good evening, sir. So in this project, basically, we'll be provided with unstructured kind of data, right? And
Uh,
we are
yes.
expected to, and we are expected from our side to build a any solution that we could think of using that particular kind of data. And it can be any, maybe some predictive models that I could build, or maybe some generative AI stuff. So it is all on me what I could bring, what I could develop it, right?
Yeah, that's right. Uh, Also, there are structured data also. In the raw data, you can find the less files, which are kind of structured data. You can find the SIGWI files, which are also structured data, as well as unstructured data that will be reports and all. So yeah, you have to define your own problem statement, and you have to build a prototype. And there, I already conveyed you the judging criteria and the key expectations.
Okay, thank you.
Okay. I believe most of you got access to the Delphi, right? If you didn't get the access to the Delphi, you can put the same in the WhatsApp group. I will look into it. And soon I will be uh, sharing the data with you. I will provide you the link via WhatsApp and via mail also. The project name will be the Hackathon data, and you can download that data and re-upload it on your new project, which you will be creating in the Dataiku workspace. Any other questions?
Yes, Jayant, you have a question?
Hello, am I audible?
Yes, you are.
First of all, thank you so much for such a detailed and very long presentation. I just wanted to know that while registering for this event, we just registered 2 members. And as you say, now you can work as a team of 4 or 5. So how we can bring those members now?
I'm very sorry for this, but registrations are closed now. So now the teams cannot be updated.
No, just to clarify,
Okay.
we allow 2% per team only, yeah? So we have just given an example that 4, 5 people can work in a single project, but in these structures, we allow 2% per team. So let's stick to that. Yeah. If 2 more person wanted to join, that could be a separate team, but now the option is closed as the registration is closed now.
Okay, means we can work as 4 to 5 people, but only 2 will be representing this 4.
Right.
Officially, yeah, 2%.
Okay, thank you.
So one question is from Shivang. Can we bring pre-trained model into Dataiku for fine tuning? Yes, you can.
So that will also depend on how heavy or light your pre-trained model is. For example, you cannot bring a pre-trained LLM model with like 8 billion parameters or something because there's resource constraint in terms of GPU and the data eco environment which you will be having access to. But feel free to use it outside Dataiku as well. You can use Dataiku for some part of your workflows and do the rest outside as well. It can be a mix and match, but lightweight models, yes, you can bring.
Yeah, I think he is talking about PyTorch or TensorFlow model, right? So those are
Yeah,
lightweight only. So
yeah,
you are
but
talking about, yeah, I mean,
yes,
fine,
even
you,
for PyTorch and TensorFlow, it depends on how light or heavy your, model is, how many parameters in that PyTorch model is. If it is close to a smaller number of parameters, you will be able to use it without any friction. But if those are still heavy models, then it might be difficult, to fine tune it in Dataiku. You might still be able to use it for inference, but fine tuning is difficult.
Yes, you can do the same outside the Dataiku. For any questions regarding the data, you can just email us, or you can put it into the uh, WhatsApp group. But I will try to arrange one more session, a 30-minute session, a Q&A session, sometime next week, where we can address all of your problem one by one regarding the data and other issues. Does this answer your question, Virish?
Vishwendra,
Yes, sir.
I think the Q&A session is complete now, or are we waiting for some more queries?
Uh, like
Because I can
let's
see.
wait for some time.
Okay,
We are here.
that's
But
okay.
if
No
you have
problem.
any other plans, you can go ahead.
No, I don't know. I just wanted to see. I think we have now how many? 76 attendees. Okay, no problem. We have instructed them clearly about the project name. Na? They have to keep it
Yes.
as their ID.
Yes.
So regarding that, I think somebody asked a question. I have already mentioned in the chat group. If you don't have your team ID, you can just mention your registered email ID in the participant WhatsApp group, and I will give you your team ID. I think that works. And in case whoever has joined and is not part of the WhatsApp group, please join. Somebody has
Not
asked a question,
able,
Vishwendra.
not able to locate hackathon data. Yes, I will show you, but right now you don't have access to it. I will provide the access by today only. Right now, no one can access this hackathon data. You are onboarded on SL Delphi portal, but the project access is not yet given. I will just give the access after some time. But by today, you will have the access. I will again show you how to access the data if that's what you want. So if you go to the delphi.com, delphi.slb.com, uh, you should be seeing something like this, my subscription. So you all have been provided with the data science subscription, or you can go to the solutions here also. You click on the Lumi. So, but only the data science subscription will have been provided. Uh, so if you launch it, you will be redirected to a different window. I hope, okay, again, this is down, but no worries. I will provide you the link of this dataset. If you just paste it here, it will provide you with the Dataiku homepage where your data will be located. The data will be named as Hackathon data. If you click this, you will be able to find 3 projects. Again, one more thing, very important thing. If you once you create your project, make sure it's a private project, because if it's not a private project, then anyone can see your work. So there are settings here. Just a second. So here are the settings. If you click on the 3 dots here, here is the security, and here you can grant access to username, email ID, or whatever, and you can edit the permissions here, what he or she can do. Right now, for this hackathon data, I have only given you the read project content and export data uh, permissions. So project visibility, you should keep it as private, not inherit global settings or discoverable, because if you do this, everyone can see your project. So make sure that you make it private and give access to your teammates only, not everyone. Okay, I just showed you how to give access to your teammate. Just go to the 3 dots, go to the security, and add user to your project. Use your email, and you can grant the access. And again, project visibility, you should keep it as private. Okay. What is the compatible format of seismic data in Dataiku, as I said,
It
SegWire?
is, yes, Pritam, so you'll be receiving the seismic data in SegWire files, but in Dataiku, you cannot directly read or interpret a SegWire file. So recommended is you can upload it as that file in a folder and then use your Python scripts to read that SegWire file using, those libraries available like SegWire IO in Python. You can just read and store it as a NumPy array. And then you can go forward with your manipulations, calculations, analysis models in the using that array. So that will be compatible with your machine learning and deep learning models.
So if you find your project name or team ID already in the uh, workspace, you just flag it to me and I will delete the project.
So in terms of prototype or deliverables, see, there is no clear requirement from our side. It should be basically whatever idea you have in mind, it should show in a working mode to us. I mean, it should not be just slides or a static content. It should be working prototype. For example, if you're working on, for example, denoising a seismic data, then your model, whatever you are making, or the demonstration which you will show us in Dataiku or combination of both, it should show us the entire journey of how you have loaded the data, how you have created your machine learning architecture or deep learning architecture, and then what was the final output. Yeah, like on your screen is the phase one submission requirements. So these are the expectations we have, that you give us your problem statement, proposed solution, a demo, architecture, how this idea is unique or novel, and what type of data technology tools you have used, and what value your solution can add to industry as a whole. And yeah, if because we understand that it's limited time, 2 weeks, but therefore we understand it would not be a full blown product, but a quick prototype or a quick POC kind of thing only. And so you can also suggest us your next steps, like what was your vision, what you wanted to do, but how far you have reached in these 2 weeks. So yeah, this is our requirement on the basis of which your projects will be scored. Yeah. So the judging criteria, etc., has been mentioned, and it will be very transparent in terms of all the criterias we have mentioned.
Any other questions? You can unmute yourself and you can just ask also. How to visualize seismic here?
See, here you can use your Python code environment, the code recipe in the notebook format as well, like a Jupyter notebook. So you'll be able to visualize like a 2D slice using some matplotlib libraries, uh, but only until here. So Dataiku doesn't have a proper visualization plat tool like Petrel. So what you can do is maybe you can get the output from here and then take it outside Dataiku and then show it to us there, or you can take screenshots of those outputs of your Jupyter notebook cells and show us if you want there.
So one more question. If we do our code in VS Code, then where should we need to submit? Okay, yes. So you all are required to make a folder in your project. You all have to make a folder, and you need to put all your. Okay, my screen is not visible, right? Just I will share it. Yeah. So you need to create a folder like this, and you have to name the folder as final submission, and that will be all. And you have to put your pitch deck, your VS Code notebooks or .py files along with the documentations of the code in this folder. And store into, try to put it as file system folders. I believe this has already been conveyed. So we just put the name as final submissions and dump all your pitch deck along with the documentation of the codes, along with the codes, everything here. Or if you are not using any other external environment, uh, if you are using the flow only, the visual recipes only, then you don't have to provide the documentation of the code. But something which we will know ki, what your thought process was in making your prototype.
Okay, so for Aninda Ghosh's question, you will get seismic data, well logs, and reports related to subsurface only, not production, right? We do not have production related reports in this. Yeah.
You can explore more once we provide the data set. After submission of the project, any presentation session will this will be conveyed later if there will be any plan for that. How many teams will be selected for phase 2? Please don't worry about it. You just try to focus on the problem statement, identify, and building the prototype. The shortlisting, we will shortlist as many as we can. Again, just want to emphasize something. Before using any data, please go through the terms of data usage, because this is very important. If you violate any of the terms, there will be disqualifications. Does the prototype have to use both seismic and well, or using anyone? It is sufficient? Also, you identify the problem which has the real world impact. That's all we are looking for. You can use anything. You can use seismic only. You can use seismic plus well log plus reports. Not only this, you can integrate all three of them. Uh, Build anything just using this data set, and which has some real world impact, and you have put your some of your creativity and your innovation into it. Kindly share today's slide as well. After submission of project, any presentation session? Okay, again, any presentation session you will be conveyed if there is any. Right now, we don't have any presentation session planned. So you have to submit your pitch deck, your codes, your results in the pitch deck, the codes if you're using external environment or code recipes. That's it, and we will evaluate. So what we are looking for, like the quality of the problem you will be solving, and your approach, your creativity, your innovation, and the use of Dataiku platform. That's what we are looking for. Please, any questions? You can unmute yourself and ask. Is there any module on YouTube or else to explore the capability? Yes, there is a YouTube channel. Also, you can find some materials on the Dataiku website. Maximum number of slides for the pitch deck. Yes, it was conveyed in the presentation. You can use maximum of 10 slides, not more than 10.
Vishwendra, I think if no more question left, we can conclude this session. The chat window anyway will be active and we have that WhatsApp group. So any question in your mind, feel free to drop. Yeah. Thank you all. Thank you for your time. We all are excited and waiting for this fantastic participation in Hackathon. Please be sure it's a teamwork. You are not working on your project alone. If you need any help, if you are stuck anywhere, feel free to reach us. Of course, there will be a time lag between our, putting a problem and a solution, but be sure we'll be working on it and we'll come back to you as soon as we can. Yeah.
Thank you. Thank you everyone for your
Thank you.
time. Thank you, Navamita. Thank you, everyone.
Thank you, Vishwendra, and thank you,
Thank
Namita,
you.
for taking these much efforts. Abhinit sir, I think Namita is also there, RK is also there. So thank you all for making this event a grand success. अभी beginning ही काफी अच्छी है, so let's hope for the best.
Thank you,
Thank you
sir.
all.
Thank you us for
Thank you,
providing us the
everyone.
opportunity.
Thank you,
And
everyone.
thank you to all the attendees who
Thank you.
have attended this program. It's a first time event, so let's make it a great success. Thank you all. And for any
Thank
queries,
you,
feel
Nikhil.
free to ask in the WhatsApp group. Please maintain the decorum over there. Thank you.
Thank you, Nikhil. Thank you, Kaushik. Bye.
Okay, thank you. Bye bye.
Thank you, Slumberger team. It's a very good